Live from Minneapolis, it's Tuesday night. How are you all doing tonight? We've got a flat earth debate. It's myself and Santosh. Now, don't be confused about Santosh. He's not Santos. He's Santosh. So, hold on a second. Hold on. Oh, you can't hear him yet. I don't want to spoil the transition. Here we go. There it is. Good day, Santosh.
How are you doing, Mike?
I am great. Look at that mug. It says, I am not the imposter among us. Not the imposter. The controlled opposition. If you missed it, Santosh was on a couple weeks ago where I did a game show with a bunch of flat earthers and told them that one of them was controlled opposition. And they had to vote off the controlled opposition each round, and they would get thrown over the ice wall. I love that. Until finally one stood as the final winner, who apparently is controlled opposition, or maybe is not controlled opposition. And that was Mallory. Santosh came in second, and he has, for coming in second place, he gets the mug. I was going to send Mallory a shirt, but Teespring won't print that shirt. For some reason, they'll print the mug. Anyway, so Mallory, you didn't even get, I know. Mallory, we need to talk. I'll get you a shirt. I'll get you a couple mugs. I'll do something. I'm gonna get you something. I can get you a shirt that's got this on it, right here. The Toon, right here, that says on the back, your inability to grasp science is not a valid argument against it. That's an option. I've got that. They'll print that. Or, Mallory, people, this is awesome. I've got a very, very expert shirt. It says very, very expert. It has sunglasses on it. It's in my Teespring. I'll get the link and put it in the chat here in a little bit. So anyway, Santosh, why don't you give us a little bit about yourself? And sure. How did you come to thinking that the earth was flat? As crazy as it is.
I am Santosh Christudas. I'm sure you've seen me here before. Also known as Jack Bliss in the internet world. So I do music and stuff, and I sing and do other things like that. And so regarding flat earth, basically the first evidence that I got was just the video footage, just the camera going over 20 miles high, and it was still like the horizon was completely flat, and it actually rose with the camera, but I never actually saw the curve. And I was expecting to see the curve, at least at 20 miles high, when I've been told that the ships go over the curve. So from 20 miles high, you'd expect to see that curve. So, and I never saw it. And I think that was one of my first revelations that was given to me, that the Earth is in fact not what they say it is. Let's just leave it at that. Right?
Okay. Were some measurements maybe involved in convincing you?
Just like on the video, like as it went higher and higher, it just said like 1,000 feet high, and then they showed the thing, and then it like
but measurements.
That's about it. Like that's the video footage that I saw.
Okay, so no measurements.
Well, that's the measurements. Just the height. That was
the height.
There.
Okay.
Yeah.
All right. Okay. I put in the chat there the Teespring store down at the very bottom. It's got the very, very expert listing with the sunglasses in it. So go have a look at those. Mallory, if you want those, let me know. Karam says, I support Witsit and her flat earth model girlfriend. Witsit's a her? Oh, okay. So you're a singer, huh?
And I heard you're a rapper. So
yeah, I'm the worst rapper in the world.
I'm the worst singer in the world. So apparently somebody commented.
Why do I believe you? Should I believe you? I believe you.
We should do a collab together. As the worst singer and worst rapper.
No, there are limits on the freedom of speech. So we'll tell you what, I will do this. One thing that right away got me was thinking about how things would have to look if the Earth was. What do you think the map looks like? Let me get that first.
I go with the what's that? The I don't know the exact name of it, but like it shows it's basically a flat disk, and then the sun and the moon kind of like go like parallel to each other, and it's a local sun and moon. It's not like it's not a globe basically where the Earth is spinning around the sun or whatever that nonsense is. So
yeah, the azimuthal equidistant map or the Gleason's map, the same thing, where you have the North Pole in the middle, and then okay. So I thought, well, if that's the case, then what if somebody went to all the way to the very far south, to the actual the South geographic pole? What would you say to that?
The actual south?
The geographic South Pole. So
okay.
So here's a video.
Okay.
From the South Pole.
Okay.
It's a 5-day time lapse.
Okay.
Following the sun. Now, if you're at the North Pole, the sun would go the other direction. But these particular buildings are quite notable as being at the South Pole.
Okay.
So this is at the peak of the southern summer, which would be like in December.
Okay. So this sun is like they always have sun, right? Basically, like the whole. How long does this last?
About half the year at the pole is sun. So the sun rises approximately at the solstice in September. So it's about to rise in a couple days now. Now, of course, it's on the edge of the horizon, and then it's up for 6 months. They have 6 months of light, and then it dips down again. But every day it circles. It's just not very high in the sky. So there, it's gone around once already.
And you're telling me that this footage is actually a period of 5 days, or like how many days?
This is 5 days.
This 5 days, okay.
Yeah.
All right. So, can I be honest? It doesn't quite look like it's 5 days. And
well, I have to be honest. It's not. Yeah. It's not in real time. It's sped up.
I know it is. Of course, it's sped up, but I mean, it doesn't look. Even though it's sped up, it doesn't feel like it's 5 days. Maybe more like I don't know, 5 hours or something like that. I mean, just from my perspective. Also, how does this actually prove a globe? That's something I'm curious to hear from you. If it is,
well, it shows that there are definitely two geographic poles, the North Pole and the South Pole, right? So there it is. This is they have the credits. I have to mute the sound because it's a song by the Violent Femmes, which is copyrighted. So so this guy here, it's a guy that's Robert Schwartz. This is from 2017.
Okay.
And vimeo.com/Polaris Lights. So you can go see, he has several other videos that he took at the South Pole there because he was stationed down there for quite a while.
Okay.
So what do you say to that?
Yeah, basically the same question I had, like, so you're basically saying because of this, that automatically proves that there are two poles.
It confirms that there are two poles.
Okay.
Two poles of rotation, yeah. And it certainly could not work on a flat Earth with the AE map as you've said that you think it is.
Okay. So, like I said, like there's also a theory. I mean, this is also being put out that there are actually two suns. There's like one like sort of mirroring the other one. Have you heard that theory?
I've heard it. It doesn't actually solve any problems because it actually introduces more problems. Because if the Earth were flat, then we would see both suns all day long and neither would ever set. And we don't see that. In fact, we see the opposite. The sun does set and there's only one that we see. So
not necessarily. I mean, one sun could be like doing its own thing, like one inner circle, and the other could be like doing the much more outer circle. So we wouldn't see both of them technically.
We would have to actually see both of them because above a flat plane, nothing ever would obstruct the sun. We'd never stop seeing it.
Oh, well, there's the atmosphere to consider, like the denseness. This, like, for instance, we can't see a certain distance, right?
Wrong.
There's only a certain distance that we can see.
No.
So
when you at nighttime,
yeah,
when you look out, say you go to the ocean and you look out over the water at nighttime, immediately above the horizon, you see stars.
Mm-hmm.
So the light from those stars somehow made it.
Well, that's hypothetically, you're telling me stars are, well, according to the flat Earth model, the stars are not as far. So
they're closer than the sun?
I don't know if they're closer.
Which is closer, the sun or the stars? In the flat Earth.
I guess the sun is technically within the dome, but the stars are not as far. Like they're kind of like on the dome or something.
Okay, so the stars are farther than the sun.
Yeah, slightly farther, not like light years away.
And which is brighter, the sun or stars?
The sun is brighter.
Okay, so if we can see stars, and stars are farther away, then why could we not see the sun, which is brighter and closer?
Well, the stars, it's like that's a good question. Like I'm not saying I know we have all the answers, but maybe stars are much bigger than the sun. And then that's why we can see.
Some certainly are, yeah.
Yeah. So, I mean, like, according to your own theory, that we can agree on, right? And also, like, when you look upwards, I think the denseness of the atmosphere gets thinner, right? So that's why we're able to see things up.
Yep.
And
the view straight up has less atmosphere than the view to the side. But still, we still do see stars directly above the horizon, the thickest part of the atmosphere. We do see stars directly above it. So the atmosphere is not blocking the stars, which are not as bright as the sun. So how is the sun obstructed?
That's a good one, but that's a good point. There could be like I'm not like completely sold on the two suns theory. But I know some flat earthers were talking about there's like one sun that just like they just sort of like do an inner circle and outer circle. And there has been, I can't be 100% on this, but there are some photos that have revealed two suns. I don't know if you are aware of.
I've seen those, and I also am aware that it's a known effect of having a lens. Mm-hmm. It's called internal reflection. There's lenses. And a better camera even has more lenses.
Okay.
And you have, when something's really bright, like maybe the sun, the reflections are then visible on the photograph.
Right.
So
there's an effect. So you've named
it's not due to two suns. It's due to just internal reflecting on within the lenses.
I'm curious, is there a video footage of the two suns, or was it just a photo that you're talking about?
I don't know if it's a video, but I can pull up. Somebody sent me some pictures the other day. Let me see here. Let's see. I get a lot of emails from people, and sometimes I don't. I try to respond to all of them, but I just can't always. Let me see. No. It was kind of recent, so I should be able to find it pretty easily here. Oh, there it is. I got it. Okay.
Okay.
So I need to drop it onto my hard drive here. topic suns dash.
Write that down.
That's how silly. Seriously, people, 2 suns. There aren't
That's photographic proof.
There aren't 2 suns. But all right, this one actually has a more than, I think more than 2, but it's like 3 or 4. Yeah, I mean it's just showing the lenses. That's why it's so such a cool picture, actually.
Oh,
Or it's 3 pictures. Let's see. All right. Finished copying. All right. 1, 2, 3. And all right, I will give the guy's first name. First name is Corn with a K. I don't want to. Well, I probably can just say yes. It's Corn Tech. And if Corn Tech wants to claim responsibility, go ahead. All right, so there is the third one. So here's let's see. All right, here's the first one in the series. Okay. This is where you can't see the sun at all, right? It's obstructed behind something, and it's not the atmosphere, because we know the atmosphere can't do it because stars. And so then we've got, so here we have actually 3. Do you see that? 3 sun, maybe even a 4th over to the right here.
Oh, the plot thickens.
Yeah. So, but the thing is, they're all the same. There's a little bit of a distinct shape to the sun there. It's a little oblong. Right. Maybe it's partially obstructed by clouds, or maybe it's just something. I don't know exactly what, but all of these other ones have the same shape. So are there 4 suns? No, this is a known effect of lenses. An effect. Yeah. And then here again we have, this looks like it's 3. Do you see that? There's one directly below it, and then to the right, it's just kind of a faint look to the right of it. Mm-hmm. So that looks like there's 2 or 3. But the thing is, the idea of the flat Earth idea that would satisfy the South Pole having a sun go around it like that wouldn't actually work well for this, because they would not be near each other. They would be far away from each other, doing different things. Mm-hmm. So, anyway, so that, I mean, it's just more to kind of chuckle at if somebody were to claim that this suggests there's 3 suns or 4 suns.
No, it looks like a reflection or something.
Yeah. So that's what happens with lenses. It's a known effect. It's not surprising, but it doesn't answer the question for the South Pole having a sun go around it. I actually saw, I love this, on Facebook. Somebody posted, a flat earther posted something like, here's what it looks like at the North Pole, checkmate globies. And it was actually from the Antarctica. The sun was going the wrong direction. And I don't know if it was from the South Pole station that one was at, or if it was at one of the others. But I mean, you could see buildings and they're identifiable. Like, that's on the South Pole. That's not working for you. So,
well, technically for a flat earther, the North and the South are the same. There is one pole, but it's just like, it's in the center, right? So there's no... Yeah, there's no.
So they say, but it doesn't match observations, because I just showed you a video of, from the South Pole. So, and there's another. All right, I'll show you this one.
Sure.
Here is, I think, I can't say if I know who it is. This is a guy with his electronic GPS at the South Pole, and you can see on his GPS 90.0. 90 degrees, 00.000 minutes south. So he's at the actual South Pole, as far south as you can go. Okay. And then when you're that far south, the longitude, it doesn't matter. But he got 5 degrees, 52 minutes or 53 minutes east. So there it is. All right. So here's the challenge. People in in South America and in the southern part of Africa and in Australia look due south.
Mm-hmm.
And they see all night long this, either the crux is a constellation they see, or they see the center of rotation, right, in the sky, which is the south celestial pole, right? The center of rotation of the south skies is the south celestial pole. They see due south. They see it all night long from sundown to sunup. It doesn't move laterally. It's fixed due south all night for everybody in all these locations. So what do they see? How could they see the same thing if they're all looking away from each other?
Well, they're seeing it from different perspectives, right? And wouldn't this work better on a flat Earth map than a globe?
It would not work at all. If you stood back to back with somebody,
okay,
right, would you see the same thing? No. If you and two friends stood back to back, so you kind of were looking in three different directions, and you look straight ahead, would you see the same thing?
No, we wouldn't see the same thing.
No. So that's what these people are doing. They're all facing with their backs towards each other and looking due south. And there's any number of ways to confirm due south. It's not difficult. People don't confuse it. Yet they see the same thing due south. All of them see the center of rotation due south.
It looks like from this image, it looks like they're all seeing the same Antarctica, like these southern wall.
Well, they don't. Nobody sees the wall. Nobody's ever seen the wall. But I'm talking about up in the sky when they look and they see in the sky the south celestial pole, right? The center of rotation of the stars.
Mm-hmm.
Or they could just look at constellations.
Yes. By the way, the constellations I've heard from Australia. If you look at it, it's kind of like it's upside down. Like it's not the way that we see it.
Yeah.
Have you heard that one? Or like they don't see even the moon or something the same way.
Yeah. That does work. That's one thing. And for some reason, the globe proponents bring that up. It actually doesn't. It works on both. So whether it's flat or a globe, from Australia, you'd see the moon in a different orientation than because you're on the other side of it. So that's a
flatter.
That's a neither. It works in both. It's one of the few things that does work in both. But this one doesn't work in both. Right. And I have evidence for it. This is from, let's see, what's his name? Craig Lias, who is a concave earther. He took this video. This is from the southern hemisphere. So this is the rotation going the opposite of what we see in the northern hemisphere. But this is due south, is what he sees. This right here. This is from Cosmic Surfer, a flat earther. Again, the southern rotation. There you go. So you can see kind of over on the right side of the screen is the sun, some moons, not moons, some clouds coming through. But you can see the center of rotation there. Again, it's going the other direction as it does in the north. And then from the same person, here's another. There you go. Due south. This is what they see.
Very nice footage.
Every night. I love using flat earther footage. And so then here is a montage of pictures that I made. So South Africa, Australia, Lake Titicaca, Bolivia. Yes, I'm 13. And then in Utah, this is the heavily skewed lens, but you can see both the north celestial pole and the edges kind of the south in this 360 degree lens. So due south for all those locations, we see the same thing. I've never heard anyone actually provide an explanation for it. It's kryptonite for flat Earth.
Mm-hmm.
Nobody's ever, they say it's perspective. Perspective is just, it's not a get out of jail free card.
It is interesting. I will tell you that. So like I said, I hate to parrot them, but it does seem like perspective wise, there's something going on, but
it's not a get out of jail free card. Just say
well,
perspective.
how does this exactly prove the globe though? Can I hear from your end?
It is evidence for the globe. Again, it is, if the Earth is a globe
Mm-hmm.
and it's rotating, then in the northern hemisphere, we should be able to look in the sky and see a center of rotation rotating one way. And in the southern hemisphere, we must see the southern celestial pole rotating the other direction as in the north. And we see it. Hypothesis confirmed.
Mm-hmm. Is there any video footage or only
I
photos?
showed you video.
Oh no, I just saw still images, really.
No, those were video.
Oh, okay.
It was a 23-second video and a 10-second video and another 10-second video. So we can show it again. Here, hold on. I'll get the 23-minute video for you.
Is it time lapse or?
Yeah, of course it's a time lapse. It takes hours for that to actually happen. So, all right, here it is. This is a 23-minute video. You're on a computer, right?
Yeah, I'm on my phone. I just want to make sure.
Okay. You see the?
Okay, I see it now. Yeah, sorry.
Yeah.
Okay, so it's moving towards the right. Okay.
It depends if you're on the top or bottom. On the top, it's moving to the right. On the bottom, it's moving to the left.
So the video could be flipped over. I'm just saying.
It's moving clockwise.
They could just flip the video over, and just pretend like it's.
They certainly could, but where's Polaris? Here's the deal. There's about 1 billion people that live south of the equator.
Okay.
And they see this, including flat earthers. People don't disagree with this. This isn't, it's a conspiracy that there is a southern celestial pole. It's not a conspiracy. Nobody thinks that that's the case. So that's not even straw grasping, right? That's too far for straw grasping. People see it. There's no argument. You could go ask a flat earther that lives in Australia. I can't believe they exist, but you could ask one. Is there a south celestial pole? And in fact, this was, like I said, this was filmed by Cosmic Surfer, a flat earther. At least that's where I got the video from. I don't know if he filmed it or not, but that's where I got it from. So, and this other one, this one here, was by Craig Lyas, or Lyas, Lyas, a concave earther. Doesn't think the Earth is a globe. And again, you can see that there is not that Polaris is not there. So,
speaking of concave Earth, maybe that's why I don't know how he became a concave Earther.
Well, it wasn't edgy enough, I suppose.
He went the whole way.
Yeah,
he went full circle.
I don't understand how somebody could go to concave. It's like, if flat Earth wasn't ridiculous enough, let me go full ridiculous. So anyway. Oh, edgy brass man. Yes, I wasn't meaning to have it be a pun. All right, go ahead.
Yeah. What are your thoughts on? Of course, there's always the simulation theory, right? So you see it from one perspective, you can see a globe. If you see it from a different perspective, so it all depends on your perspective. So
well, it's a hypothesis that cannot be tested. So great, it could be a simulation. Don't know. We can't test it. But if you don't mind, I got a couple super chats. I think this first one is excellent. Adam Lord for £10 says, in your last debate, you said that variables aren't one of the primary constituents for an experiment. What are the actual necessary parts of an experiment? In UK schools, we have to state our variables. So that was probably when I was debating Austin Whitsitt and KY. So let me do this. If you Google Berkeley Understanding Science. It has a fantastic website on how to do science, and it's written to an entry-level college about, right? So a bachelor in college level. And then I'm gonna actually scientific method. So what happens is, like, you have flat earthers like Riley and QE, Quantum Eraser, they bastardize science. They took a website that is share it to you so you can see it too. Took a website that was a middle school how to do science class, or how to do your science fair project. And for a middle schooler, you give them the entry level stuff. You tell them how to do things at a middle school level. You say, all right, well, if you're going to do an experiment, here's how to do it. We need to give you a cookie cutter approach. But when you get more advanced, that's not the case. It's like music, right? Day one of music class, you don't put Beethoven's symphony in front of the kid, right? You say, all right, you're going to play a note, and then you're going to play a second note. Here, you're going to play a scale, right? Now you can do the scale. All right, we're going to have you play a song in the key of C, so there's no sharps and flats. Right? Okay, now you're getting that. Now we're going to introduce complex rhythms. You can, if you've ever done music, it builds. Same thing with science, same thing with math, same thing with every topic, basically. So the scientific method that's sent to middle schoolers or even high schoolers is not the end. It is not, it's not dogma. And that's what they've done. They've taken the scientific method, right? Like this one here has like 5 steps. They'll take the 3, 4, 5, 7 steps of scientific method, and they'll say, this is the absolute only way to do science. But actually, no, there's more to science than that. So on this, I'll put in the chat for people. Are you music savvy too? Yes, I played music. I played a lot of music in high school, so I learned a lot and forgot a lot. So Adam Lord, there's the link in chat for you to look at how science works right now. I haven't answered your question yet. I'm getting to it. Ask a question, formulate a hypothesis, perform an experiment, collect data, draw conclusions. That's what they have here. That is too simple. Right there, it says too simple. It's a good outline. So if you don't know what to do, if you're wondering what's the next step to do, then go ahead. But in reality, in their work, scientists engage in many different activities in many different sequences. Scientific investigations often involve repeating same steps many times to account for new information and ideas. So what about variables? So the kind of the template is that the variables are, you have your independent variable, your dependent variable, and your control variables. Absolute excellent things, but not a necessity. It's not, oh, you didn't have these 3 things, therefore it's pseudoscience. That's not how scientists actually evaluate whether an experiment or somebody else's science is valuable or correct or accurate or useful. That's not how they do it. They look at it. They say, is it internally consistent? Is it logical? Does it make sense? Did they control for the things? Do they have control over it? Did they control for the things that they needed to? And did they examine the things that they must? Right? And so there isn't actually a necessity for an independent variable, control variable. What you do need to have is a hypothesis and a prediction, right? So you have a hypothesis, a prediction. That's it. You don't need to actually go and control something. You just make a hypothesis. You make that prediction. You say, oh, well, look at that. Observation matches. Now, you can get much more complex than that, and you can get much more specific than that, and often you will need those variables. So it's awesome here. This process of science is not predetermined. So now this website, let me look at it, show you here. It's actually interactive. Yeah, you can see here.
Wow.
It goes now. They also have a this is, I don't know what they're using on this. It used to be Flash and they updated it.
I think it's HTML5 or something.
Yeah, that and CSS and whatever.
Yeah.
So theory building, coming up with new questions, ideas, benefits and outcome, right? Testing ideas. Does it support a hypothesis? Does it oppose a hypothesis? So I'm not going to go over all of it. It'll get too long. So then the next part of the question, in UK schools, we have to state our variables. What level? My guess is that it's not college level. Maybe it is bachelor level, but certainly not when you're actually doing research at master's or PhD level. So there we go. This has some fantastic things, including plenty of talk about how science does not prove things, because as soon as something is proven, there's no more question to it. It's totally certain. And a famous scientist said this about proving or about being certain in science.
And that makes the science uncertain. If you thought before that science was certain, well, that's just an error on your part.
Richard Feynman, that was, saying science is not certain. And if you thought it was certain, that's an error on your part. So there we go. That's the answer. I hope that does well for you. And if you were with me the last stream, we talked about, like, my wife is like, you should do science stuff, like do a science channel. Like, I definitely would. I've been thinking about doing that. So I hope we homeschool our kids, and she's like, hey, we could just play it for our kids. Exactly. So, all right. That was, I hope that was worth it for you, Adam. Excellent question. Thank you for it. Indie Tiger says, for $5, there has to be an invisible sun, gives its heat to everyone. And then notes, and then The Police, which is the very first tape that I owned, was by The Police. Synchronicity.
Oh.
Yeah, you want to sing that song there for us, Santosh?
Which one was that?
There has to be an invisible sun, gives its heat to everyone.
Oh, is that a song? Oh, I didn't know that song.
I actually don't recognize it.
Yeah.
I should. Now that I said that The Police was my first album that I owned.
You.
It's talking about creepy songs, stalker songs. Every breath you take, every move you make, I'll be watching you.
There you go. That's
a stalker song. Somehow it came out as a love song. I don't know. Another stalker song. Have you heard of Boston?
Yeah, I've heard of Boston.
What's their creepy stalker song?
No, I don't know.
It's Amanda.
No.
I'm gonna take you by the hand and make you understand, Amanda. I'm gonna take you by surprise and make you realize, Amanda. Like, I can't wait another day. Like, hold on a second, dude. Back off a little bit. You're getting a bit too intense.
It's how you say it, I guess. I'm gonna take you by the hand, Amanda. Or if you said, I'm gonna take you by the hand, it's like how you sing it and how you say it. It's all about the tone.
I don't know. If you just look at the words, I'm just looking at, you could play with the tone. So, all right. Now the Sun Express has a question for you, Santosh.
Yes.
How do cartographers, that's the people that make maps, how do cartographers know how to draw the sizes and shapes of countries?
That's an excellent question. I've always wondered about that. Like, I guess they just go to the edge of the shore, and then they sort of just, okay, this is the edge, and then they just make a mark of it, and then they slowly just
walk.
Walk along, and then just sort of.
that. Somebody had to at some point survey the area. Yeah, so they have surveyors. Surveying is the general answer to that question. So yes, and surveying is pretty intense work, and they've been doing it for centuries. And surveyors
Yeah.
are pretty stinking good at it. Uh, they know where the boundaries of countries
Yes.
are, where the boundaries of states or provinces, if you should live in Canada, um, cities, even people's properties,
Yes.
and they've done that. The big ones they have to use. They have to be more precise. So
Right.
when you're doing this a state, for example, you have to use the shape of the thing we're standing on, because
Right.
it will modify the map if you do it wrong, if you ignore the shape of the thing we're standing on.
Interesting. So are you trying to prove the globe using this, or like?
I'm saying that surveyors must use the sphericity of the Earth as part of their work
Not
when they
necessarily.
do
It
surveying.
could be a flat disk, and they would still know the shape of the country, or yeah.
Distances are all different. They're greatly affected by the shape of the thing you're on.
I disagree with that one. The same way some people think, oh, if the ship, how do you like some globers will say, because the ship can go like around the globe or whatever, that's why we know it's a sphere. But the ship can go like in just a certain path, right? The same thing, like.
Sure, but the distances are drastically different.
Hmm.
And depending on the map that the flat earther might suggest, because the AE map that you've suggested is not the only one. There's a handful of other maps that flat earthers have proposed. None of them work. David Brock. David is if I remember right, knows a bit about surveying. So here's the deal, Santosh. Then they need to know distances, right? So somebody could go and they could get the latitude and longitude for a point on the shore, right? And then they could get the latitude and longitude. They can do that using the positions of stars in a nautical almanac and stuff like that. And then they can go to a mountain and say, all right, well, here's this. And then they can go over to the river that's on the other side of this particular state or province. That's the border.
Right.
And get the points all up there, the whole length of the river. And the distances between these different points, then they would calculate. How do you calculate the distance between points on the Earth?
I mean, it could be done on any. It doesn't matter if it's a globe or a flat Earth. The distance will be the same. That's what I'm trying to say. Because
but math disagrees.
Okay.
Because if you're so if you just take a two-dimensional coordinate system, an XY coordinate system, Cartesian, right, and you have 2 points on it, how do you calculate the distance between those 2 points?
Well, you measure it like. Say, for example, if it's flat, and if you could still put that flat disk over a globe, right? Like, and then wouldn't it be the same distance? Let's just say hypothetically, it wouldn't be the same distance.
Hypothetically, they would not. I'll let's see. I'm looking for my marker.
Sure.
My marker. Oh, my marker's gone. Somebody stole my marker. A pencil. It's not as good as a marker. Eddie Reese wants me to say the name of that lake again. Remember the name of that lake?
Lake Titicaca. I like your laugh. You sound like a 13-year-old and you laugh like that.
Lake Titicaca.
What a name. Somebody was trolling. That's for sure.
I think they might have said it in a different language. Okay. I have resolved the problem of a marker with a marker. This came off. There we go. Get in there. All right. So if you have 2 points, right, we have our Cartesian coordinate system here. Got it?
Okay.
See? Great. You got 2 points here. You got that and that. You got let's call it 2, 2. Made that too far, right? And then up here we've got 4,4. It is. Oh, it's not 14. I did that on accident. I can't erase it. 2, 2, and 4, 4. How would we calculate the distance between these 2 points?
By measuring it, obviously, like
No, if you can't go and measure it.
okay. I'm not sure.
Oh, come on.
Longitude
Come on,
by-
Santosh.
longitude-
Where did you go to school? Was it in the US or in India?
Well, it's part
or
US,
Canada?
part India. Part US, part India.
Okay, so high school.
Yeah. Oh, it's been a while.
Where did you go to high school?
Oh, in India.
In India. Okay.
Yeah.
Do they not teach the Pythagorean theorem in India?
Yeah, they did, but I draw a blank because I took biology from 10th grade onwards. So, like they have like you don't have to take math after a certain class.
You should have.
Yeah.
So here we've got the distance from 2, 2 to 4, 4. We've got this distance is 2,
Okay.
and this distance is 2, right?
Okay.
So this diagonal distance, we use the Pythagorean theorem. So 2 squared plus 2 squared is, so it's 4 plus 4 is what?
8.
8. So then we take the square root of 8 to get this distance, which is just a bit less than 3.
Okay.
That's the distance, right? So on a flat surface, that works. But on a different shaped surface, it doesn't work the same. So if the Earth were flat, then you could use the Pythagorean theorem to get the distance. If the Earth is spherical, you would have to use a spherical coordinate system based formula. There is one, it's called the Haversine formula. That is actually what people use. That's what cartographers use. It's what navigators use to calculate distances. And the Haversine formula and the Pythagorean theorem formula get drastically different results the farther you go. So the amount of fuel you might need for your trip would be different if it were flat versus if it were spherical.
Okay, so let's do something very basic here. See, I've drawn a point here, A. I don't know if you can see it, but A to B, right?
Yeah.
So this would be, let's just say this is a certain distance. Now, if I do this, does that change? Does the point A to point B, does that change? The measurement, does it?
Yeah, on a cylinder like that, no.
No, well, make it a globe. Anything you want. Make it a
if you
curve.
make it a globe, it absolutely changes, yes.
So if I made this paper into a globe, the point A to point B would change?
Get out your scissors, make that into a globe.
No, I'm asking you.
You can't make that piece of paper into a globe.
I'm saying that hypothetically, because if it's a curve doesn't make this point A to point B any longer or shorter, right? So basically,
it does. Just a second.
Curvature would not add anything to the measurement, nor does it being flat. This is very, very basic.
Yeah, and you're missing. It's a great point, and you've kind of self-defeated, but you don't know it. So you can't make this piece of paper into a globe. You know why? You'd have to get rid of a bunch of it, right? So you could cut parts of it,
yeah,
to make it kind of shape into a globe, right? And so what would happen is you'd wind up cutting these into this path in order to make it into a globe, which would change the distance.
I don't think you would have to. Let's say we had a ball. Okay. Say you had a ball. Okay, right now, just any ball. You mark point A and then point B, right, on that ball. I don't know. Do you have a ball?
Well,
so
we can imagine you do it on an orange, and then we could peel the orange.
And then we deflate that ball.
Yes.
Okay, it's completely deflated. It's completely flat. Would the distance between A and B be the same, or would it be different?
They'd be different because you cannot take an orange, peel the orange, and then lay the orange peel flat. It will you have to cut it?
No. I'm talking about ball here. Just a
take
ball.
an orange.
Okay.
An orange is a ball, right?
Again, you're going back to an orange. I'm talking about a beach ball. You mark
all right, fine. Take a beach
with
ball.
the marker, you mark one part A and the other part B, right?
Yes.
And then you draw a line across from A to B.
And then,
now you deflate that ball. It's flat. It does the distance between A and B.
Wait. How did you flatten the ball? Did you just let it sit there and it's all wavy?
I just release the air and it's flat.
Okay. But part of it is on the ground and part of it is facing up, right? So you got it.
Yeah.
You got it.
So
what you're going to need to do is you're going to need to cut that.
Why would I need to cut it?
Because it's not flat like the flat Earth, right? Right.
Could be mountains. You could consider those little ridges like mountains.
Oh no.
It would be the same length.
Oh no.
Those
mountains on the Earth would be many hundreds of miles high, much higher than any mountain. The thing is, half of it is facing up. What if A is on the up side and B is on the downside? That doesn't work. That's not the shape of the Earth. You don't go over the edge of flat Earth and come to the bottom of flat Earth, right? You think the whole thing is flat. You think it's the AE map. You cannot take the surface of a sphere and flatten it without lots of cuts.
My theory is the distance between, like, whatever mark I made, like the distance between A and B would be the same, whether it was a ball or if it was flat. That will not change.
But you have to modify it in order to flatten that ball. You have to modify the ball, which would cut into any route except for radial routes.
But the length would not differ. What I'm trying to say, Mike, is the length would be the same. So you're telling me that because the distance between this country and this country is different because it's a ball, and it would be different if it was flat. I just proved to you very simple that distance would not change at all. The point A to point B would not.
Actually, what you've done is you've shown that you don't quite get the geometry. So, all right, hold on. Geistview sent me something. What is this, Geistview? Hold on. I need to mute that. Where's it? There it is. He wants me very much to show something to you here. It's the August moon. What is that? Tony has a good point. Use 3 points on the globe. The distance between 2 points might be the same. Radially, they could be, but the distance to the third point will change.
How will that change?
Because like I said, if you flatten a ball, you have, if you just let it sit on the ground, half of it is pointing up, half of it are facing up, half of it is facing down. You need to have all of it facing the same direction first, because you're not claiming that the flat Earth has an underside to it, and like you go to the equator and then like there's a 90-degree turn and we flip to the underside of it, right? Unless you're changing your idea for the flat Earth.
I'm not. I'm just talking about the distances. The distances would not change.
They would because in order to do that, you'd need to get your scissors out, right? You'd cut. You just pick one side. This is going to be the middle, and I'm going to just start cutting, and you're going to splay it out like rays all pointing out in a different direction. And as they get farther from each other, or farther from the center point, the gaps between those cuts are going to get drastically larger. So the route that you made on the sphere part of it, when you spread it out and then you lay it on the ground and now you measure between those 2 points, there's going to be some on the ball, and then there's going to be a gap. There's going to be some on the ball. There's going to be a gap, and you measure that distance. It's going to be different.
I'd love to see that actually demonstrated, like a line drawn between these points, and then when you measure the line, it's different when you deflate it. That would be very interesting. Line. If that line can magically stretch longer or shorter based on
it's been like 2.5 years, and I'm still always amazed.
I'd love to see that experiment. Like it seems pretty basic.
I'm always amazed that you can't think in 3 dimensions. But I should not be surprised. I just should not be surprised anymore. All right. Geistview said I was looking on I need to look on Twitter for the DM. So I'm looking on Twitter. Oh, that's it right there. All right, I'll take that. Hold on. This might help you. Save image. To downloads. Twitter adds. I hate Twitter's download thing. It adds this. It doesn't name it .jpeg. People, you ever get this problem? It names it .jpeg_large. Thanks a lot. Thanks a lot. All right. Santosh. Have you heard of the other guy, Santosh?
Who was that?
Santosh Bonacci?
No.
No.
Is he also?
It's
Maybe
for the
he's
best.
I think
He's a flat earther, but he's not a nice guy. He's quite horrible. All right.
Because I know there's a Spanish name that's Santos, Santosh. So
I think he's Italian.
Oh
I
yeah,
think that's where it's. Yeah, Italian, Spanish, same thing. I'm kidding, people. Don't get mad at me. But, all right, hold on. I got this for you. I got it for you. I'm gonna share it so you can see it. There you go. All right. You see that? Here's the flat ball, the ball that flattens, and so you see there's a red side and a blue side, and you flatten it, and then on the left there's just the blue side, but you see there's cuts.
Mm-hmm.
There's cuts. There's gaps between them. So if you on that ball on the right, if you drew a line from just staying on the blue section, and if it jumped from one section to the next, right? And then you flatten it, and then on the left side, you see the flattened version of it. There's that gap. And so if you put your ruler down from point A to point B, it's longer.
Mm-hmm.
Right? So that's only half of it. You're still missing the red half, right? So if I drew a line from the blue part to the red part and then flattened the ball like this, how do I even measure the distance? Because it's the blue part is up and the red part is down. It doesn't even fly anymore, right?
It's interesting toy.
So
is that
it's just a flat ball, PHLAT ball. So there you go. All right, let me somebody else had said something to you. So let me where'd it go? Here it comes. We've got, all right, I'm just going to say it again, Lake Titicaca. All right. Connell Silverfirst says cartographers walk 500 miles and they walk 500 more just to be the ones that walk 1,000 miles to show up at your door.
And I would walk 500 miles and I would walk 500 more.
There you go.
That song? Is he referring to the song?
That's the song. Cartographers would do it. But Santosh, You're not a cartographer.
No, I'm not.
You probably wouldn't pass the math test. And Eddie Reese says, say the name of that lake again, Toon. Titicaca.
You do a song just on that, Titicaca. Or a rap.
Okay. The Sun Express says, Santosh, now that you know a thing or two about cartographers, explain why Antarctica is the size and shape we say it is, and not an ice wall. Ditto the circumference of the Antarctic Circle, which is smaller than the equator.
Okay, so basically you're confirming that the Antarctica you drew like on the globe is 100% real. Is that hypothetically?
Well, that's what the cartographers, who it is their career to do this, that's what they've done, yes. And there's reasons why they've done it. They've used the Haversine formula in part to measure distances.
Right. Antarctica is like, you do realize that nobody's actually been to Antarctica, like the public are not allowed there. There's a lot of restrictions there. So basically, whatever they say.
True at all, actually.
Not, well, I mean, you could maybe go to a certain small part of Antarctica.
Not even remotely true.
So there's nothing that we can actually First of all, how many?
Don't just
Do you
quote
know anybody
somebody.
that's been to Antarctica?
Don't just quote somebody. Okay.
Do you
I
know
know
anyone?
some. Yes, the guy
Okay.
that sent that flat ball picture, Geistview,
Yeah.
he's been to Antarctica.
Okay.
Let's see. There's somebody I think in the chat right now who's been to Antarctica. I was emailing with a guy who's on TikTok who is currently stationed. He overwintered at Antarctica. His something turns the globe. If anybody knows his name on TikTok, send it to me. I've emailed back and forth with him a couple times, asked him if he wanted to come on. He said, no, the bandwidth there just isn't good enough to do a video chat. There are thousands of people that have been there, including Metallica did a concert there. So when you say you can't go there, that's not true, because I know why you say that. Just tell us, why do you think that we can't go there?
Well, first of all, it's an extremely cold climate. I think
Absolutely,
most humans haven't been.
But why do you think we're forbidden from going there?
Has any human actually gone all around Antarctica, like the whole Antarctica? Like I heard that there's a certain point you can't go beyond.
There's people that have done cross Antarctic journeys on snow machines, on vehicles. They've flown it, and they've
Cross
done
Antarctica, like they cross the entire Antarctica.
Start at one edge, pass through the South Geographic Pole, keep going, and get to the other edge. So Fumduckery was there on a when he or she was in the Marines. We've got Geistview was there on Murdo, Black Island, from May 2017 to April 2019. Eddie Reese has been to Lake Titicaca. There's a race around Antarctica, a boat race. I think a sailboat race. Yeah, the Vendée Globe is what it's called. But yeah, a guy did either snowshoeing or cross-country skiing, like he was human-powered, him and maybe a couple other people, I think, but went all the way across it. So people have done it. And if you want to, you could too. Now, it's not cheap, because you need stuff. You need to get there. It's not cheap to get there. You need to bring stuff with you because it's freaking cold and you'll die otherwise. So the places that are like, well, we'll fly you there, but we're not going to fly you there if you're not bringing the right stuff, because we don't want to have to go get you when you're dead. So they're like, you're not getting on our plane until you show us that you have boots and this, and right, to make sure you're going to be safe. So
are commercial planes allowed to fly over Antarctica? That's just an argument.
Yeah.
So they're allowed to fly over Antarctica? Because I heard their argument, they're like flight patterns specifically designed so that they don't fly over Antarctica.
Well, there aren't a lot of large airports there. In fact, there are none that are paved runways. So there are ice runways. So if you're in a 747 and you need to do an emergency landing, where do you want to do that emergency landing?
Not on Antarctica.
Not Antarctica, absolutely. You want to do it on a nice paved runway. So, or you want to do it where somebody can get you, right? So you might go near the edge of Antarctica and make more sense. But the thing is, if you were to go from in Brazil, one of the cities in Brazil, to Perth, it's almost straight across. You'd almost hit it. The problem is it's not very practical. There are already 5 weekly flights strictly in the southern hemisphere that go very long distances, right? So they go across. So there's Perth to Johannesburg, right? So you can go between Australia and South Africa. You can go South Africa to South America. You can go South America to Australia. All these combinations are covered. All of those 5 different flight routes don't work on the AE map. They're drastically different distances and routes. So, Geistview says there are flights all the time crossing during the summer season. They go from base to base. Okay, yeah, they're not commercial flights you're going to go get a ticket for. But if you wanted to, you can fly from Sydney to Santiago, and you could look out the window to the south and see the ice flow. So PJC Net is telling you to give me a debate. He's a flat earther. So all right. So here's there's a couple things you can do from the comfort of your living room to see what the Earth is like, right? So you know that Uber works in Australia, right?
Yeah.
In Melbourne, in fact, they have Uber. So GPS works in Melbourne, Australia, the southern kind of edge of Australia. And latitude and longitude works in Australia there, right? And so there's 360 degrees around the globe, or around the whatever, right? Around the world.
Yeah.
And the distance between them is 1/360th of the circumference of that latitude, right? So the equator is the latitude in the middle. I'm at 45 degrees north here in the Minneapolis-St. Paul area. You're, I think, a little farther north, right? Then south of the equator at 45 degrees south, it would be, if it were a globe, it'd be the same circumference. And if it were flat, it'd have to be larger. So we can do something. We can go and we can look in just on Google Maps, and you can go and get a distance between 2 points in the city of Melbourne where Uber runs, right? And you can measure with Google Maps. It'll tell you the distance between the points, and it uses the Haversine formula. And then you could use the polar distance formula, right? So if the Earth were flat, there's two major options for coordinate systems. One would be Cartesian, like I showed you here, right? But latitude and longitude isn't Cartesian like this, right? Latitude and longitude is, if the Earth is flat, would be a polar coordinate system where the latitude is the distance from the center, and the longitude is the angle. I don't know if you did polar coordinate systems. They are covered typically in Algebra 2, which would be junior level in high school. In fact, I just today went over that syllabus with one of my kids. Polar coordinate systems and transforming between different coordinate systems. So the polar distance formula would be what you'd use to get distances between points using latitude, longitude. If the Earth were flat, of course, that's not what we use. We use the Haversine formula. So you could look at Melbourne, and you could do that, and you could say, all right, well, I'm just going to take 1 degree or 1/4 of a degree along one line of latitude in Melbourne, and I can measure the distance, and I can say, does that look right? Does that seem right? Okay. And then I can just do the math to find out the whole circumference of that line of latitude. All by yourself in your living room. You could do that. And then you could say, wait, is that more or less than the equator? You can do it yourself. In fact, I've done it. I have it on my website. It's not linked. Whenever a flat earther says, hey, I need evidence, or I need to know what you're going to be doing, I send them this, and then they never come back. I don't know why. It scares them away. But I will, there it is. Using Google Earth to get the radius of the Earth. It's actually 4 different ways to get the radius of the Earth using Google Earth or Google Maps. And it is, I think it is the, let's see, which one? There it is. Polar, it's I'll start right here. I'll share it to you too.
Okay.
So if Uber is right and GPS works in Melbourne, then it's hard to actually argue this. Is it Melbourne? Yeah. In this example, we take 15 arc minutes, so 1/4 of a degree, from -37 degrees, 45 minutes, line of latitude. So I'm not going to go over all the details, but 22 kilometers is what it's supposed to be.
Mhm.
And you look right here. Let's see. There it is. So this is all within the city of Melbourne. There's that. Yeah, there's zoomed out a little bit, and there it is zoomed out even farther. And it actually gives us the radius of the Earth accurately. So there it is. Multiply by 360, you get the line of latitude or circumference. So 31,733 meters. So 31,000 kilometers is the circumference of that line of latitude south of the equator, which is less than the 40,000 kilometer radius of the equator. If the Earth is flat, it can't be less. It has to be more. But it never measures as more. There's no measurement for being more. So, what do you think? Are you convinced?
No.
All right, then. So you don't have an answer for the Sun Express, who's asking, ditto the circumference of the Antarctic Circle. How did they measure the radius of the Antarctic Circle, or the circumference of it? That's one of the ways they could do it. They could go to a point, measure their latitude, longitude, go to another point, measure their latitude, longitude, and then measure the distance between those 2 points. They could walk that 500 miles or whatever to measure it.
Yes.
So, all right. Kuros, another one for you, says, Santosh, every map projection requires a mathematical formula. If the Earth were flat, my job as a cartographer would be way simpler. Look up Tissot's indicatrix. I have no idea what that is.
I've never heard of that.
Me too. I'm going to look it up right now. Tissot's. I'm probably pronouncing that wrong.
Flat Earth cartography would be easier, and maybe that's how
certainly would, but it doesn't
I mean,
work.
that's how they've been doing it for so long. If you think about it, because they didn't have that kind of technology that.
Yeah, and they didn't have accurate maps until they did better map making. They couldn't get far from land because they couldn't. They didn't know where they were.
So, according to your, theory, history, when was the time when they actually went out into space and actually saw the Earth, like the countries and how they were and everything? What
Into
year
space? Well, I mean,
not the actual
people
shape.
people have made globes for more than 500 years with accurate positions of things on it.
How did they do that without actually having something in space, though? Like
because cartographers don't take pictures of space, pictures of the Earth from space to know where the Earth is, right? They use latitude, longitude. They say, well, there's dirt here. Latitude, longitude. There's dirt here. Latitude, longitude. That's where the shore is. Okay, well, let's remember that and note that down, and then we'll, like you said, we'll follow the shoreline and we'll map out where it is.
That can be done on a flat Earth. It's
it could be, but the coordinate system wouldn't work. So this book here, in Inventing the Flat Earth, Columbus and Modern Historians, goes after two different people that claimed that Columbus era people thought the Earth were flat. They did not, in fact, think that. Columbus, sneaky guy, he in order to get funding, he needed to convince the people that were going to fund him that he could make that distance work. He fudged the numbers. He intentionally shrunk the radius of the Earth through multiple different steps of intentional omission and very sloppy estimation to claim that the Earth was smaller than it was. And if America hadn't been in the way, if it was just water, they would not have made it. He got lucky because the Earth was, because America was in the way.
flat. Yeah.
So how did they do that? Well, cartographers knew And once they got good three-dimensional or not three, latitude longitude measurement systems, then they were able to do that. So they didn't need to go to space to do that. So they've been doing they've had accurate maps since the 1400s, or accurate globes since the 1400s. So when did people first go to space to get photographs of it? That I think in the late 40s, early 50s was when the very first photographs from space were taken. But nobody used those early photographs to map out where things were. It was already well mapped by then. So was there more to your question?
Well, also I heard the theory that they made the countries look bigger or smaller, or continents. Have you heard that theory? Like, than they actually were? Like Africa is supposed to be even larger than what they actually show.
So yeah, so on anytime you take a spherical surface and put it onto a flat surface, you have to distort it. So the Mercator projection, or in the similar projections to the Mercator projections, tend to skew things north of the closer to the poles and south of the poles. At the extremes, it tends to distort them more. And the things in the middle are the least distorted. So since a large portion of Africa is on the equator, Africa is generally not as distorted as North America and Europe and Asia. So North America, Europe, and Asia looks bigger on a Mercator map than they should if you're just looking at a globe, compared to Africa. So people have said, well, that somehow is mean to Africa because it makes Africa look smaller. I don't think that it really matters that certain continent sizes are skewed or not. I don't think it's intending to diss anyone. So I don't think it was intentional, but people have since then been more intentional about it and said, well, we should maybe choose a different projection that tries to not do that. So they've used different map projections, some that are cut. If you've ever seen where like it's got this curve going off, between maybe Greenland and Iceland, and then you've got the same thing between Alaska and Russia to undistort a little bit the different continents, but there's no perfect projection. It depends what you're trying to accomplish. Mercator projection works well because angles for certain types of navigation works. But if you're doing air navigation, they tend to use a Lambert conformal conic projection, which I have on the wall here, because it uses secant lines north or above and below the midline of that map where the distortion is 0. Above it, it's one way, and between it, it's in the other direction. It lets you use, if you don't get too large on your map, it lets you use just straight linear measurements to estimate distances close enough that you can get your fuel consumption requirements without having to do the Haversine formula. So
it's not 100% accurate. We can
what's
both
that?
agree on. These cartographers are not like 100% accurate.
There's nothing is 100% accurate ever. But when you plot the Earth on a globe, the accuracy is extremely high. And when you plot it on different things, different projections, there are distortions. And depending on what you're trying to do and what you need that for, you may choose a different distortion technique so that you can use it more accurately. How's that?
Okay.
Man, you're popular, man. Santosh from the Sun Express says that the good Homolocene project is the spherical map laid flat. That is why the A to B points won't be in the same location. Now I gotta look that guy up.
Okay. So the A to B, the line between A to B would be different.
Oh yes, that's what I was talking about. I'll show you. So if you drew a line from South America to Australia on a globe, and then you use the good Homolocene projection, which I'm maybe mispronouncing, and then what would happen is it would have gaps. I'll show you. If you just drew a straight line, you see that?
Yes.
Here it is zoomed in, because there's cuts in it. So that's what I was talking about. So like if you take an orange peel and try to lay it flat, it doesn't, you can't lay it flat. So there's a great example. So that does a good job to have Europe and Asia and North America not be skewed to be disproportionately large. And you can tell, yeah, Africa looks on this particular one bigger than North America, which is correct. So, Tony Regime, if maps were made to increase the importance of countries, they would be centered on London, as the UK had superior naval navigation when most maps were made. That's funny.
True.
So, all right. And then he said something about the Tissot's indicatrix. So that shows the different projections. So there's the Mercator projection. You see the dots there? That shows the amount of distortion that each area experiences from that projection. You can see how big that is, like over Alaska. That's distorted a lot compared to along the equator. And definitely on this, you can look at Africa, you can look at North America, you say North America looks bigger, even though it's not.
Africa's tiny here.
Yeah. So all right. Thank you. That's a excellent point there. The Sun Express. Foam Dockery says, MC Toon, he is thinking that if you draw the continents all on the northern hemisphere to keep the distances, he's just flattening, not thinking about the southern hemisphere. True. Your map, you draw your lines on that ball and deflate it. You can't jump hemispheres. It doesn't work. Cretan Ball says, you're nice and polite, which puts you ahead of most other flat earthers, but you're really struggling with some basic things. There's hope for you. Santosh, what would it take? What would convince you?
I don't know, maybe see it for myself one day, the actual curve. I'm very observational. Like you can do all the math in the world.
But here's the deal. You were convinced by not seeing yourself.
What's that?
You were convinced that the Earth is flat by not seeing it yourself. Shouldn't you use the same standard of evidence?
I'm just convinced with what observations I can see. It's flat, it's stationary. I don't feel the rotation and things like that. It's just basic. Yeah.
Do you expect to feel the rotation?
I expect to see something.
Feel
something.
Do you expect to feel rotation?
Yeah.
Why? What's the limit of the human body's ability to sense rotation? Do you know that?
No.
Now, if you're going to say you think you should feel rotation, you should have a good idea of what the human body's ability to perceive rotation is before you say, I think I should feel it, right? To be fair, you should know how much you can feel rotation. Right? If you go on a merry-go-round and you spin it fast, you can feel the rotation, right? Now, if you're on a merry-go-round and you spin it really slow, do you feel it?
But the thing is, it's not spinning very slow. It's spinning like 1,000 miles per second.
But spin isn't about the linear speed. It's about the amount of angular change. So in different cities, they have these restaurants on the top of a building that's rotating, right?
Yeah.
Yes.
Yeah.
Now, when you're in there, you don't feel it moving, right?
Are you sure about that?
I don't know. I'm.
You feel
it takes a while for it to move, to rotate, right?
Yeah.
Have you been to it?
No, I haven't been to it,
Okay.
but I've been to things like that. And you feel something, even when you're on a plane. There's some vibrational.
Yeah, but you feel vibration. You don't feel speed. Right. So anyway, the point is, if you're on a merry-go-round and you're spinning, if you take you let it spin, take an hour to rotate it once, you wouldn't feel the rotation. So the deal is, the human body can feel rotation, but it's not super sensitive to it. And the amount of rotation of the Earth is much, much less than the human body's ability to feel the rotation. So we should not feel the rotation.
Ever. That's it. Like,
No,
even
because our bodies aren't sensitive measurement devices.
and does the rotation ever change? In your theory, does the speed ever change? Does it vary, or is it always the same?
The variation, there is variation. It's extremely minute, but there are instruments that are able to measure the change in rotation. I have a few of them on my website, mc2.net/spin.
Oh, and what about the moon? If the Earth is always spinning,
Hold on. We can't go on to 10 different things at a time, right? So here is several experiments that measure the rotation of the Earth. And this one in particular at the top, how to detect the Chandler and annual wobble of the Earth with a large ring laser gyroscope. Actually, that's not quite what you were asking about, but you're asking about the difference in rotational speed. So one of these actually has, they were able to, not that one. They were able to measure the difference in the rotation of the Earth that happened because of an earthquake. One of these, I think, I don't know without saying it. But if you were to look at these, I'll tell you what, I'll send you these and you can look. They actually do quantify the difference in rotational speed of the Earth before and after an earthquake. It's very small, but they are able to sense it. Now, some are optical, which would mean that they're they use the Sagnac effect, which is the same thing that airplanes use in their high-end ring laser gyroscopes. These are not mechanical gyroscopes. These are, they call it a gyroscope, but it's not really like the same kind. But there's other ones that are very different that are also able to measure the rotation of the Earth. This one here, superfluid phase coherence, uses liquid helium to measure rotation. This one here, a diamagnetically levitating gyroscope. It's a plastic ball that they're rotating using a magnetic field of 15 Tesla, and then they measure the change in rotation of that ball over time. Here's one from 1905. Anybody's a fan of the what's that TV show from the, oh my goodness, in England, you know, that TV show in England that I'm thinking of. What's
There's so many shows
from around Downton Abbey. So this is shortly after Downton Abbey, or shortly before. They measured using this. They have these cool pictures of the device that they made, that they spun up this disc and they spun it really fast, suspended it from wires, and it rotated. They measured the rotation of the Earth right there.
So they're able to measure it, but just not feel
Absolutely.
it.
Yes. Because it's an instrument that's designed to measure very fine rotation. We don't possess that inside our body. There's no part of our anatomy that is really good at sensing rotation. So,
and I don't know if you've seen this photo where there's like a cloud of smoke or something that's rising above the Earth's atmosphere, and it's still like if the Earth was actually spinning underneath, right? You'd expect the smoke to dissipate or like move or something, right? But it's still completely.
Do you know the laws of motion?
So, like you're telling me, every action has its opposite and equal.
There's three, so that's one of them. Yep.
Yeah, and then
an object in motion
is forgot that one. Yeah,
will stay in motion unless acted upon by something else, right? So because the air is rotating with the Earth,
I
you
heard
wouldn't
that.
expect it to just fly away any more than when you're in an airplane. You jump up, you don't expect to get flung to the back of the airplane. It's
Are you sure about that?
conservation of momentum.
If you jumped out of an airplane,
No, inside an airplane. You're in the airplane.
so you're basically saying it's a dome then. So we are within a dome.
No. Don't go there. I'm explaining to you conservation of momentum. Don't get off on a tangent. I'm just showing that's how conservation of momentum works. You're in an airplane, you jump, you land, you don't go flying back. That's not how conservation of momentum works. So the air is moving with the Earth as it rotates.
Okay.
So the air, the volcano or the smokestack, it goes up because everything's rotating with the Earth. Now, of course, there's wind, and wind will move things around, and that's different. But here's the deal. As things move, there is Coriolis, which will curve things slightly if they're not steering, right? If they don't have their own internal ability to steer. So I'll show you what happens with a volcano due to Coriolis. Right there. So that's in Iceland, a volcano that was a few years ago. And so this is a picture from a satellite of the curve. You see how it's curved? That's due to Coriolis.
Is like, what was this taken from? Like a
satellite.
Satellite. Okay.
So that is so just the point is that's what you'd expect to see with just that slight amount of curve due to Coriolis. So when you say Earth rotating underneath, it's not really the right way to think about it. Coriolis is a slight force applied to moving objects. So if something is moving straight up, you wouldn't expect to have any Coriolis at all. So a hot air balloon, you wouldn't expect it to, because it's disconnected from the Earth, it's not going to just lose its momentum. It still keeps its momentum, right?
So at what point do we actually leave the atmosphere and the Earth and like actually see the spin from space? At what height?
So there's no specific height, right? So the deal is you need to, number one, get rid of any rotational momentum that you had. So you need to get far enough away that maybe you don't need to be in orbit anymore. So that's pretty far. So there's actually where the Discover satellite is. It's in the Lagrange point. I'm not going to explain it to you right now, but anyway, it's a point where a satellite can sit. It doesn't have to rotate. It's about 1 million miles from Earth, and it can just sit there and not move, like rotating around the Earth. So the Earth rotates independently of it. So yeah, and so the Discover satellite does show the Earth rotating.
And what about the moon? Is the moon spinning with the Earth, or is it just the Earth that's spinning and the moon is stationary? Because we always
everything's moving.
Oh, so the Earth, the moon is actually spinning exactly with the Earth, or
not exactly? It's slightly off. There's something called libration, and so the face of the moon that you see, I don't know. Anyway, if this is right, it slightly moves a little bit like that throughout the month. And so we don't see half of the moon. We see slightly more than half of the moon because we see a little of that side and then we see a little of that side as it wobbles a little bit in relation to us. But yes, it's called tidally locked. We see generally one face of it is facing towards us. It's because the makeup of the moon is not perfectly evenly distributed. So there's parts of it that are slightly more dense than others. And so because when it's in orbit, then it over time, many, many years, will tend to lock itself in that orbit. So apparently other moons in our solar system around planets, for most of them, or at least a large number of them, are also tidally locked like that.
So that's why we never see the dark side of the moon. So that's
well, we see the dark side of the moon half of the month, and we see the bright side of the moon half of the month.
How come one side is dark? If that's, I mean, maybe that's a silly question.
So, well, all right. So to be clear, it's the other side of the moon, or the back side of the moon, you might say. That's what we don't see unless you're an Apollo astronaut, or if you're, we've had other satellites around there. You don't see the back side of the moon. The dark side of the moon is the part of the moon facing away from the sun, which changes about every 28 days. Mm-hmm. So your question is, why is there a shadow on the moon? Why is only part of it lit?
We only see one part face lit all the time, and then
it's because if you had a spotlight on the side of your face and the rest of the room was black, you'd only see that side of your face, right? You wouldn't see this lit, right? And then if the light is here, you'd see your whole face. Then if the light was here, you'd see the other part of your face. And if it was directly behind you, you wouldn't see any of it. It'd be dark.
Wouldn't somebody from the other side of the globe be able to see the dark side of the moon? Since, like,
if the Earth were flat, you certainly would. But because it's so far away from us, right, as many thousands of miles away from us, moving several thousand miles within the Earth to view something that's many thousands of miles away, it doesn't change enough. You see a slightly different angle to it, but it's not appreciable amount.
And what are the phases of the moon? Like, sometimes we see a half moon, a full moon, a no moon. Like, what's that all about? Why does that happen?
Are you serial?
What's that?
Are you serial? You don't know?
No, I'm just from a globe perspective. I know, like, the phases of the moon also is the same as the cycle for the woman or something. Like, there's some kind of connection.
All women are different. You're married, aren't you?
Yes, I am, but I'm just asking. Like, I'm asking from a globe perspective.
It's about 28 days. It's not exactly. Yeah. I knew a girl in college that had it every 2 weeks. Poor girl. Anyway, oh geez. Why did I know that it was every 2 weeks? Some people share too much. So what are the phases? The phases are just names that people have given to different times and different portions of the moon that are lit. You've got a new moon where it's almost none of it is visible, or none of it's lit from our angle, and a full moon where almost all of it is lit. And waxing and waning, quarters, slivers, halves, whatever. It's just names that people have given to it. It's kind of arbitrary. You could choose to divide it into thirds or sixths if you wanted to. If you wanted to be musical about it, you could have octaves of it, and have 13 phases to them. It doesn't matter. So.
And it's all from the sun. The light. Your claim is the moonlight is actually a reflection of the sun.
Yeah, the sun's light is reflecting off the moon. And you can confirm that by going out any time that you can see the sun and the moon at the same time, which is many days of the year. Hold a ball at arm's length right up next to the moon, right? And the shape of the sun the shape of the part of that ball that's illuminated on the ball will match the part that's illuminated on the moon. And that's because between you and the moon to the sun, it's very, very far away. Again, we're going in these huge distances, so that the angle between your ball and the moon is actually very slight when compared to where the sun is. So the sun casts the same shadow and the same illumination.
Have you seen those photos where you can actually see the stars like through the moon? So
I've never seen stars through the moon. I've seen people claim it, but I've never seen stars through the moon.
It's like almost the moon is a hologram or some kind of transparent.
I've seen lots of people claim it, but I know you haven't seen it because nobody's ever shown it. ever. There's never been stars seen through the moon.
Or you see the blue sky through the moon. So it looks like the...
Yeah, you're not seeing the blue sky through the moon. You're seeing the
I've seen
blue, and you're seeing the moon not illuminate it. Not illuminate the part that's not illuminated. So you just see the, right?
It looks like it's transparent, though. I mean,
it does. It is a bit of an optical illusion, but it's not actually transparent. Because you can take photographs of the moon when it's dark, very dark, and see the non-illuminated part of the moon if you adjust the exposure on your camera right.
Mhm.
PJC Net says it can happen. I've heard people say that you can see stars through the moon, but I've never seen anybody actually show it. Ever. Have you seen it? You think you've seen it? You've not seen it. I've heard people say it.
I've seen it on Google. Like when you search it, sometimes you see like images like that. But I have seen the blue sky through the moon in the daylight. You see, it looks like it's transparent.
It is an optical illusion. I have seen still photos of the moon with dead pixels from the camera.
Mm-hmm.
That if you didn't understand what dead pixels were in a digital camera, you might think were stars. But here's the deal. You can actually see stars get obscured by the moon, or people have taken video of things like planets going behind the moon, and it gets obstructed by the dark side of the moon, or the unlit portion of it, and it doesn't go through that part, and then it appears on the other side again. So
yeah, I've seen even footage of clouds going behind the sun.
how high are clouds?
They're not high as the sun. I mean, according to
according to you, even how high are the clouds?
According to the flat Earth, the sun and the clouds are the same.
How high are the clouds? Just answer that. How high are clouds?
Maybe 10,000 feet. The highest clouds or something like that. Yeah.
Let's say less than 100 miles. How about that?
Okay.
Okay. Now, if the sun were less than 100 miles high, right?
Mm-hmm.
And you are in Canada, which means you're at least 3,000 miles from the Tropic of Cancer, right?
Okay.
So the Tropic of Cancer is the nearest point that the sun ever is, where there's a subsolar point. So on the June solstice, the sun is at the Tropic of Cancer. That's the subsolar point. It's directly above that, right? And you're somewhere around 3,000 miles, maybe slightly less than 3,000 miles from there. Now, if the sun is 100 miles high and 3,000 miles away, how high would it appear in the sky? It would not be at a high angle. It would be way low, right? If you drew a triangle that was 3,000 inches on one side and 100 inches high, what would that angle be over here? Tiny.
Mm-hmm.
So by flat Earth, the sun could not be in front of the clouds, because that would mean that the sun would have to be so incredibly low that it wouldn't make any sense anywhere.
Well, the flat Earth does say the sun does rise a little bit, like, and then it sort of, but not to the extreme.
Yeah, but you can just draw a triangle,
yeah.
Santosh, and you could look at that triangle and say, nah, it's too small. It could never appear to be high in the sky, right? So I'm at 45 degrees north, right? And on the equinox, the sun on that day of the equinox, the highest it gets is 45 degrees above true, right? So above true level. Well, it could not be just 100 miles high. It doesn't work.
But have you seen the footage though?
I've seen it, and I know what's happening. It's again,
okay.
it's because you're not a photographer, are you?
Not a professional photographer.
No. So
No.
it's just called exposure. There's a book by Brian Peterson called Understanding Exposure. Whenever a friend of mine or a family member or somebody gets a new camera, a good camera, I go buy them that book and send it to them. Because it's a great book to explain to you how to take pictures and expose things properly, because it's one of the bigger challenges. You take a picture of something, you don't want somebody's face to just be all washed out because the sun is blasting in their face, right? You don't take a picture midday with everybody with their face on the sun, because it'll get washed out. And same thing, you wouldn't take a picture of a person under a tree midday with a bright house, like a White House behind them with the sun hitting it, because they're going to just be a dark silhouette, right? It's going over stuff like that, including then understanding how thin wispy clouds could appear to be behind the sun somehow because the exposure of the sun just blasts, overpowers them, and how thicker suns then appear to be in front of it, or thicker clouds appear to be in front of it. So PJC Net says the sun isn't a physical object, which is wrong because it emits light and heat. How is it not a physical object if it emits light and heat?
Does
that make sense to you?
Well, I think...
Does it make sense that something that emits light and heat isn't physical?
I think it's like okay, you turn a flashlight on, right? And then you see the light. Yeah, it's kind of like a light. It's not a physical, you can't really...
Yeah, but the flashlight is physical.
Yeah, the light...
The flashlight is physical and it emits light. Okay, so how could something that emits light and heat not be physical?
That's a good point. I don't know.
It can't be. Even more to the point, we have bounced radar off the sun many times. Multiple times, people have bounced radar off the sun. Again, on my website, mctoon.net/sun, I have some awesome pictures of the actual array that they used to do this. It was quite a while ago, because I don't think people would be too happy with this amount of radar today. But here's a picture of the array that they used to send these radar signals to the sun to bounce radar off. It took about 1,000 daily radar experiments were made of the sun at El Campo, Texas, since April 1961. So I have a couple different papers by different people at different locations at different times that did the same thing. And it took just a bit under 1,000 seconds for the radar to get back. So not only do we know that the sun is a physical object because we can bounce radar off it, but also we know how far away it is, because we know the speed of light and we know how long it took. So it's between 89 million and 93 million miles away, according to at the time that these measurements were made.
So 93 million miles away. Wow.
Measured, not guessed, not just made up, not just we want to fool you, but actually measured.
And have you seen the footage of from the pilot's point of view, where he showed the sun was actually under the clouds?
Yeah, draw a picture of how that would work on flat Earth.
I'm just saying what the video footage I saw.
Yeah, but draw a picture of how that would work.
Is that an optical illusion? Am I seeing something that I'm not supposed to?
It's predicted on the globe, but it doesn't make any sense on flat Earth. So here.
Under the clouds? You mean the sun being under the clouds?
Yeah.
Why would the sun be under the clouds?
Well, on flat Earth, it wouldn't. So here's stop sharing this. So anyway, mctoon.net/sun, actual empirical measurements of the distance of the sun. So there you go. Here we go. Here's the sun.
Okay.
And there's clouds. How, right? Because the sun could not be lower than the clouds, because it would be like right above the horizon for us where we live, right? It has to be higher than that. In fact, I've measured it from Minnesota. If the Earth is flat, the sun is 3,105 miles high on the day of the equinox. From Minnesota, of course, it's different if it's elsewhere, so it doesn't work too well. Anyway, so how would the bottom of these clouds get illuminated? Because in the afternoon when the sun sets, you can see the bottom of the clouds are illuminated.
Yeah, how would it, like, unless it's a local
on flat Earth, on a local sun on flat Earth? How would that work on this drawing? How could the bottom of the clouds be illuminated?
Well, there's different layers of clouds, right? Like maybe you're showing the lower clouds. There's higher clouds, so
3,000 miles high. Are the clouds 3,000 miles high?
Not 3,000, maybe
No,
less than for sure. But there's different layers, so.
But all right, so not 3,000 miles high. But I personally measured the height of the sun on the day of the equinox from Minnesota to be 3,000 miles high. So how is the sun illuminating the bottom of the clouds that are less than 3,000 miles high?
How could the sun be 93 million miles away and still?
A different question. Different question.
Explain it to me like I'm a 5-year-old. How could that sun that's 93 million miles away still be able to light something under the clouds? Like how?
All right, we're coming back to this.
Okay.
All right, hold on.
I mean, 93 million miles is a long way.
It doesn't matter. Doesn't matter how far away it is. All right, this is not to scale. There's the Earth, the globe, and there's a cloud. Okay, and here's the sunlight.
The sun should be always on the top, but I've seen it light.
The sun is that way, very, very far. There's the ray of light coming in, hitting the bottom of the cloud.
But I've actually seen
not to scale. Not to scale.
I totally get it. So I've actually seen the sun actually like amongst the clouds. I don't know if you've seen that video footage from the pilot.
This explains that perfectly. Now, back to this. Explain on flat Earth with a local sun how the underside of these clouds were illuminated.
Well, the sun, like I said, it changes the altitude, right? Like even on the flat Earth.
But I measured the height of the sun on flat Earth to be 3,105 miles high.
Okay, it varies. It goes up and down. What time did you measure that though? What was it during noon time?
Local solar noon.
Noon. Okay, noon is when the sun is at its highest, right?
Well,
and then
12 hours later, it's local solar noon for somebody else somewhere on Earth. So, and I can tell you for certain that at 45 degrees latitude, 12 hours later, the measurement's the same.
Oh yeah, from their perspective.
3,105 miles high. So, again, how could so at sunset, right, when the bottom side of clouds are illuminated, how could this sun here illuminate the underside of clouds? Now, if I draw the clouds very, very far away, it doesn't fix the problem, does it? Because the angle is still going to be coming this way. It's still not going to hit the underside of the clouds. So it doesn't work too well.
But like during the noon, it'll be a little at a certain height, and then as the day progresses, it goes lower.
But somebody else somewhere on Earth also can measure the sun at the same latitude to be the same height. There aren't many suns. Mm-hmm. There's only one sun. If there were many suns, we'd see all of them.
Mm-hmm.
So it's not lower. 12 hours later, the sun isn't no longer 3,105 miles in elevation. If the Earth is flat, it's still 3,105 miles in elevation at 45 degrees north latitude on the equinox. So how are the undersides of the clouds being illuminated?
I don't know.
That's the right answer. That is the correct answer.
I don't know. Honestly, that's right.
Yeah.
We don't know everything.
And the next part of the answer is it's not actually possible. Because it's not like it's a occasional thing. It happens often.
Hmm.
I have a folder full of images of photographs of people taking pictures of the sun illuminating the underside of clouds. So, all right, let me read a couple more things here. While you ponder, how could that be? Stevie B for 10 pounds says Lake Titicaca, just for a laugh.
Just to get you to say that.
I love that. All right, the Sun Express says, Santosh, on the flat Earth, a full moon in the northern and southern hemispheres would have to show two totally different sides of the moon. That's worth a picture, isn't it?
Isn't that what happens? From Australia, they see a totally different side, and
No, they see the same side, just not the
no,
same
wait.
orientation. They say this it's the same if you just flip the picture. Right?
Well,
So,
according to Planet, the moon does not spin, so that would
it
make
has nothing to do with it.
Yeah,
Here
'cause
we
they-
go.
that's why they say the same.
Here's flat Earth.
Yeah.
Here's the moon on flat Earth, right?
Okay.
Here's somebody in one hemisphere and somebody in a different hemisphere, right?
Okay.
Now, when they look at the moon,
Yeah.
this guy's going to see. Let's say it's illuminated like that. This guy's going to see what? Mostly dark, right?
Yeah.
And this guy's going to see what?
Like the lighted side of the
Mostly light, but that's never observed. People in opposite sides of the earth, in fact, everybody all around the globe on the same day sees the same part of the moon all the time. But if the earth were flat and the moon were local, different parts of the earth would have to see different parts of the moon. Because if it's 3,000 miles high and this distance here is 6,000 miles and this distance is 6,000 miles or 3,000 or whatever, it doesn't matter, many thousands of miles, then the angle to it is drastically different. They'd see a completely different part of the moon, but they don't. Is this another I don't know?
They see the flip side, right? Like something like that, or
Well, they see it upside down.
yeah.
But that's not the problem. The problem is they'd have to see a completely different part of the moon.
And you're sure when we have a full moon here, they also have a full moon there?
Yes, I'm sure of that.
Okay.
Nobody doubts that, Santosh.
There's no change in angle because you said the moon is also like rotating.
No.
There's no there's no change in that at all.
I suspect that you were fooled into thinking the Earth was flat because you were not aware of some of these things.
I'm just asking.
Because one of my earliest thing when I was presented with somebody saying that the Earth is flat, that I'm like, well, yeah, we'd see different parts of the moon, but we don't see that. So anyway, thank you, the Sun Express. David Brock says, I would recommend a book for him to read, but I'm not sure if he would believe the author. Would you read a book from David Brock? He kind of knows his stuff. Yeah. Would you read a book from him?
What's it called?
He hasn't recommended it yet.
He's
He's first wondering if you would even believe the author.
I'll try the ebook. I mean,
The
that's
ebook. A PDF of it? All right, so David Brock, he might read something if we can get him a PDF of it.
Or you can send it if you have a physical copy. I don't mind.
There we go. I have your address.
Oh yeah.
I'm not telling anybody.
Privacy safe.
If you want to send me anything, it's MC Toon, NASA Secret Moon Base number 27, the moon. Oh crap! I shouldn't have told people that. Hold on a second. I keep forgetting I'm not supposed to tell people about the secret NASA moon base. So
Because you won't get your NASA funding now.
yeah, it's anyway. All right. You got to look at the camera, Santosh. There we go. All right.
Where
That
am
was
I?
close. That was close.
Oh my God, where am I?
Hey, how you doing? We're in the
I'm
middle of a
good.
debate.
All right, thank you.
All right. Super. Anyway, there we go. David Brock, send it to me. And we'll get it to him. What it is. Graham Price says, Dear Santosh, does Santosh think every mission from every space agency, plus every one of the tens of thousands of pictures are all fake. Isn't that a bit silly? So all the people that have been to space, over 500, are they all lying?
It's a small club, 500 people out of, I don't know, 6, 7, 8 billion.
So yes or no question. Are they all lying?
I believe so, yes.
Okay.
Because one thing, we haven't been to the moon in
That
over 50 years.
doesn't change. You're still claiming that these people are lying. Doesn't matter how long ago they went to the moon. You're claiming that they're lying. Even the people that are still alive, you're claiming are lying, including
To a very high location in the atmosphere, but not actually into space. Because by their own admission, they've said that we cannot leave the vacuum of Earth or something.
Maybe you want to work a little better on your quote there.
We cannot leave.
We cannot, with today's technology, we don't have the technology to go to the moon today. Correct. But we did in the 60s and early 70s. This is from Charlie Duke, guy that travels the globe today talking about it. And he signed this book for me right there.
Well, that's nice of him.
He says he went to the moon and you say he's lying.
It's a very small club, but the ones that went to the moon, it's even smaller.
Yeah.
So,
all right. So it must be. So what about the 15,000 photographs taken on old-fashioned cameras?
again, the technology now is much better in every way. Like the cameras are better. The car.
What about the 15,000 pictures taken 1969 to 1972? What about those pictures?
It could be just close-ups of the moon from Earth. You could do that, right? Like you had the very close zoom.
No.
It doesn't have to be on them. You don't have to be on the moon to take a photo of the moon.
No.
You know?
Oh my goodness. All right. I've never seen such behavior in the war room before, says for $5. Santosh, you seem like a nice guy. As skeptical you are for globe evidence, bring the same skepticism for flat Earth and you'll be fine.
Nobody can say, I don't know if it's 100% flat. Nobody can say that. And a lot of flat
here's what he's saying. Use the same standard of evidence when you're looking at both things. You're like, I saw a video or a picture of a high altitude balloon and it looked flat. Right? So if I sent you a high altitude picture of a balloon that looked curved, what should your response be? You should take that evidence the same, right? I showed you video of 5-day time lapse from the South Pole. You should look at that and say, hey, there's no way that can work for flat Earth. That's good evidence, right? And I've seen most people just say, it's all fake, right?
Like I said, it could be our perception. But
to have the same standard of evidence, you now need to explain it for flat Earth. Because there's a perfect explanation for the globe, right? No. There's a person actually at the South Pole and the Earth is rotating. Perfect explanation. The geometry all works, everything works. None of that works for flat Earth. So come up with an answer for it or say, yeah, that's another thing on the side of flat Earth doesn't work. Right? Because illuminating the underside of clouds doesn't work for flat Earth. South Pole 5-day time lapse doesn't work for flat Earth. Cartography doesn't work for flat Earth. People have been to space doesn't work for flat Earth. No photographs of the entire flat Earth from high elevation.
That'll never happen.
Right. So
unless we go past the firmament.
So all right. No evidence of the firmament doesn't work for flat Earth.
There's some video footage of rockets colliding, and well, there's video evidence as well.
You talked about it last time, but it's actually just staging, between first and second stage of rockets, which explanation for the globe, but doesn't work for flat Earth very well. All right, Chronic Avenger says we only noticed change in the net acceleration. I think it was what we were talking about before, about feeling rotation, right? There's no part of the human anatomy that feels linear speed, right? So we're 1,000 miles an hour. Our body can't tell the difference between 1,000 miles an hour and 0 miles an hour. We only feel the difference in acceleration. Now, a rotation is acceleration, but it's very, very small when it's 24 hours to rotate once. Okay. Alyssum says, the one time a flatty showed me a star on the moon, it was literally a speck of dust. Only noticed because it was in all of his photographs. And yeah, I've seen it. It's as either dead pixels, which of course shows up in all of them too. You got something going on? String News 1 says, would you read a book? No, I'll wait for the movie to come out. You gotta charge your phone?
Yeah, I just have to charge it a bit. Yeah, you can go ahead with the chats.
Okay, all right. Tribal Guy 2 says, why are lighthouses built tall?
That's another fascinating topic, the lighthouse. Lighthouse, like if you say these ships go over the curve or whatever, right? Lighthouses technically wouldn't work because how would the light go over the curve and like reach the ship, right? It would have to be flat.
They don't. That's why they build them tall. The taller a lighthouse, the farther it can people can see it
can go over the curve.
What's that?
If it's tall enough, it can go over the curve.
Yeah.
The light.
Yes.
How does that work?
The geometry works very well for it. I mean, I got a picture that'll kind of show it to you. I already drew. Getting a lot of pictures today. I should bring this to give my pictures to Joe Hill when I meet him. I'm gonna have lunch with him sometime here. I was hoping this week, but I'm too busy. Right here, like if it's this high, right, then you can get over the curve. Right?
How tall is a lighthouse, by the way? It's not thousands of miles high or thousands of
feet high. That's obviously not to scale. But the taller a lighthouse is, the farther it can be seen.
Okay, but we're talking about the curvature of the globe here. So how tall is a lighthouse? I've seen like 2 or 3 stories high.
There's no one height for lighthouses. They're all different heights.
Yeah. So explain that to me. Like how would that work? I've seen lighthouses that are like 3 or 4 stories high.
Yeah,
that's not tall compared to the curvature of the globe. How would that work? How would that?
Yeah, so they don't need to be indefinitely tall. They only need to be tall enough so that when ships get close, they know where they are and that there's maybe something for them to hit, so they should avoid it. That's why. So they don't. So if they're like, well, offshore here, a certain very far distance away, there's an undershore formation. Well, we better make this lighthouse significantly taller. We can do the math so we know how far somebody will be in order to see it. Or, well, we don't need to make it so tall because it's not that far away where there's underground structures. So we don't need to make it. We just put it up on this bluff here. Right. But the formula is the same formula as we use to get the distance to the horizon. Right. And without refraction, it is one of the quantum eraser's favorite formulas, 1.22 times the height of the observer in feet. That's the distance to the horizon. So right around there is how far away a ship that doesn't have a crow's nest would be able to see it. So, and of course, ships don't observe. Lost my cap to the marker. Ships don't have their lookouts eyes half submerged in water. They're up on the ship, and higher is better. So
personally, I think lighthouses work better on a flat Earth. That way, that would make much more sense because the distance, the light would be straight.
Okay, and what's the distance? At what distance? What's the formula for the distance on flat Earth that a lighthouse will be obstructed?
I don't know the formula, but I'm just saying, like, from a common sense perspective.
I know the formula.
The curvature. What is the formula?
H equals 0.
H equals 0. You just made that up?
No, there's nothing obstructing it. There is no reason for you not to see it at any distance.
What do you mean? Like,
If there's nothing between you and an object,
okay.
you should be able to see that object. Now, if it's too small to see, you wouldn't see it. But if it's a light source,
Yeah.
you would see the light source as a pinpoint light source. So it doesn't matter how far away you are from a lighthouse. If it's high enough to be above the waves, so maybe 10 meters, then it doesn't matter how far away you are, you would be able to see it, provided that it's plenty bright. So there's actually no formula for flat Earth for obstruction.
Well, there's the
nothing.
atmosphere thickness. There's other factors that might.
All you need to do is be brighter than the dimmest star that you can see. Right?
Oh, stars
we already established you can see stars directly above the horizon. So all you need is a light source that's brighter than the dimmest star you can see, and you will see it at any distance because the atmosphere doesn't block the dimmest star that you can see. So, so there you go, tribal guy. That's why lighthouses are built tall. Magellan says, Santosh, what are satellite TV dishes pointed at? And
radio towers.
Do you have evidence? Towers.
Radio towers.
Now,
why are there radio towers? So many.
So, fun fact, Magellan is in Singapore.
Okay.
Singapore is where?
Near Malaysia.
Yeah. In relation to the equator, where's Singapore?
It's kind of nearer to the equator.
Very near the equator. Yeah. So the satellite TV dishes in Singapore are pointed where?
Pointed towards their
straight up.
Straight up?
Pretty much straight up.
Yes, usually an angle as far
not in Singapore. In Singapore, they're pointed straight up because that's where geosynchronous satellites are.
It could still be and still like point like this, right? Like towards their radio towers. Doesn't have.
I'll give you if this is where your dish is pointed, and the radio tower's here, it's not pointed at the radio tower.
Oh no, it's like on the same level, so it could still like transmit like this.
But dishes are they're highly directional. Mm-hmm. Right? You know that. So that's why the dish is there. Its angle that it's receiving its signal from is very small. So if it's pointed up, something over here and something over here doesn't work. So it's not pointed at a tower. Now, my parents used to own a cabin in northern Minnesota. Right? And I personally got on the roof and aimed the dish. My brother-in-law was down in at the TV telling me which way to move it. Okay. Now when I was slightly off, it didn't work. When I was slightly off the other way, it didn't work. I had to line it up in a very specific direction. Now, in northern Minnesota, I can tell you with 100% certainty there was no tower.
Radio tower, no radio tower.
There was no tower, because you couldn't see it. So in order for a radio tower to somehow be sending it to that dish and be far enough away for me to not see it, it would have to be many miles high. And that would only work for that location. It wouldn't work for somebody 50 miles east or west of me. So you'd have to have another radio tower that nobody sees and nobody knows where it's at, and somehow you can't get to it.
Okay, so you're telling me it's going through space, through the atmosphere, into space, something that's magically floating around in space.
It's not magic. It's science. Well, yes.
You can't see that either, right? Like, and yet you're telling me that's what's causing the satellite dish
that's what's sending the signal. Yes, a satellite in geosynchronous orbit.
Okay, so and that's moving all the time. It's
in orbit above the equator, and its angular velocity is the same angular velocity as the Earth. So it takes 24 hours to orbit, and it takes 24 hours for the the Earth to rotate. So it actually stays above the same point of the Earth all the time.
So during all that time, say you're in your cabin and then you're pointing that satellite upwards, and that thing is just rotating around the whole Earth.
Yes.
And without any interruption.
Yes.
You're getting that transmission.
Yeah.
That you're 100% sure of that. Or
Yes.
do you think, oh, there's a local, which is more credible? Or do you think there's
since we can easily confirm that there is no local tower, we can eliminate that possibility. Because you can't see it. My neighbor's from India, they're from the Punjab, and they have a dish and it's pointed due south, and I can look up in the sky and there's nothing there. I don't see a tower there.
I don't see a satellite.
But of course you don't see a satellite. It's tiny, but a tower can't be tiny. Right? For a towers, they're guy towers, right? They have these structures and they have these wires that go down in order to stay vertical and not fall down. You would see them. You'd see lots of them. They'd have to be everywhere.
They are in a lot of places. Have you seen radio towers? Though?
I have, but there aren't enough. There's radio towers around Minneapolis. They're mostly on the north side of Minneapolis. All of our dishes point south. There's no towers there. You'd need to have towers everywhere for a tower to feed your dish. There just aren't enough. Not even by a factor of 1,000.
Mm-hmm.
But and Mute Donkey has a point. You can see satellites.
Oh, really?
There's websites that'll tell you what satellites are above you, and you can go out at night and see them.
Oh, it's actual. Oh, okay. So, there are satelloons. Don't get me wrong. There are
no.
Like
we're talking about satellites. Satelloons, balloons cannot steer themselves, so they would just go wherever the wind brings them. Number one, so they wouldn't be stationary. So if I pointed the dish, then the balloon is going to be at a different spot tomorrow or a year from now. But that dish sat on that roof unmoved for years. If it was a balloon, it would just move around with the wind. If there were lots of them, so many of them, right? That even if one moved, there'd be another one to fill the spot. You'd have to have many thousands and thousands of them because that dish had a very narrow angle that worked, right?
Mm-hmm.
So, but if that was the case, then I wouldn't have to have a very narrow angle because there'd be satelloons everywhere. I could just point it anywhere and they'd all work. That doesn't work either. So we can put the satelloon idea into the bucket of it doesn't work.
But wouldn't your dish need to keep moving because your satellites in space are moving? Like, wouldn't it have to like move all the time with the thing? With the
well, like I said, it's in geosynchronous orbit. It's a very specific orbit.
Okay.
Like I said, it's directly above the equator.
Mm.
And it rotates at the same rotational velocity as the Earth. The Earth takes 24 hours to rotate. The satellite takes 24 hours to rotate. So from our angle, it is stationary. It does not move. Of course, we're moving, but when you consider where we're at in orientation to us, it does not. Yeah.
Okay.
Towers and satelloons don't work, right? You've heard it. You've heard these vague claims, but you never actually tested it. You never applied the scrutiny. Hold on. You never applied the scrutiny to those claims that you're trying to apply to the satellites. So be consistent with yourself. When we're done, think, does the satelloon and tower idea, does that actually work? How could that, what would that take? How many people would have to be involved in order for that to happen? And how could it be that the dish has to be so specifically aligned? And if I point it to the side, there's somebody in this other east of me 50 miles that would have to have the tower, a saddle or something that would have to work, but it doesn't. It only works, right? Anyway.
But Mike, I have seen satelloons and I have seen radio towers. I've never seen satellites.
Does the fact that bicycles exist mean that motorcycles don't?
I've seen both and I've ridden both.
But bicycles exist and Motorcycles exist.
But if I've never
Satelloons
seen a
exist,
motorcycle-
and satellites can exist.
But if-
The
but if I've
existence
never
of one,
seen one-
the existence of one doesn't mean the other cannot exist. Right?
if I've never seen a motorcycle, then or nobody's ever seen one, or there's no videos.
But people have seen satellites. Many people have seen satellites. Many people
love
have
to
worked
see
on
videos.
satellites. You can see videos of satellites every month being deployed, including either yesterday or today. There were 60 satellites deployed. You can watch the video. So it's not like I've never seen it. You can just go see it if you want. Right?
In space. I would love to see it in space, rotating, thousands of them, or how many ever it takes. If anybody has that footage, I would love to see it.
What do you mean of thousands of them?
How many satellites are in space?
A lot. Yeah.
So I would love to see a footage from space of those satellites just moving about.
You know what I'd love to see? I'd love
Yeah.
to see a video of all the germs on my hand.
Oh boy.
How many germs are on my hand?
Well, you can see it through a microscope. So they have
Absolutely.
the
So, but I can't see
telescope.
all millions of them. There's millions of them on my hand, but I can't see all millions of them. I can
I'd
only
love
see a
to see
couple. I
one.
can only see
one
a
in-
couple, right?
One-
Yeah. So
Show
you
me
can
one
see
satellite.
satellites,
Yeah.
but not all of them at the same time.
No, I'd love to
Right.
see one. Just show me one in space.
And,
Anybody have-
and then what would you say?
I would just see it.
If I showed you one, you would say what?
If it's clear enough, if it's
Because
shot
here's the
in
deal.
HD,
If you really wanted to see just one, you could have on your own Googled it, because there's lots of them. There's lots of opportunities for you to go see videos of satellites in space. SpaceX does a launch often.
all right, I've seen them launching. Yeah, that I'll agree.
No, you can see the video of them deploying them in space, in orbit above Earth.
I've seen CGI of it, but not video. Unfortunately.
How did you determine it was CGI?
Well, they show like they themselves say it's CGI.
No,
They say how
SpaceX
it was-
does not say it's CGI when they're deploying the satellites. They say it's an actual video.
All right, I'll check it out. I mean,
Okay.
I've tried this. I've been through this.
All right. The Sun Express says, Santosh, why is the Earth not allowed to be a sphere? Titicaca.
Why is he allowed to say Titicaca all the time?
I don't know.
It's not allowed to be a sphere. I mean, you can believe whatever you want. Like flat Earth, my thing is flat Earth and the sphere kind of work in their own way. And some people who have done astral projection have actually gone outside this
Whoa.
realm. One person said, "Oh, they saw a globe," because it's from their perspective, right?
Astral projection.
Yeah, going out of body and actually going to beyond the space or whatever, beyond the atmosphere. And they said, "Oh, I've seen the globe," and that's fine. That's from his perspective, and somebody else could see it, and they can see a flat Earth.
And this is credible how?
What's that?
And how is this credible?
It's from your perspective, Mike.
But no, it's astral projection. How is astral projection credible?
Oh, they've done experiments on this. Like they've actually put something on the roof, and somebody astral projected, and they were able to go to the roof and get the actual number. We've done a lot of studies on this one.
Yeah.
I've done it
Tell you
myself,
what.
but not to that extent.
I've you know, the I forgot the name, Randy, that had a challenge for people.
Oh, that guy. Yeah, he's a bit of a fraud, by the way. He stopped that challenge, by the way.
Well, because he's dead.
He's still alive. Randy's still alive.
No, he's dead.
He's alive. Check it right now. Check it right now. I would know if he's dead. He's like 90 something years old. And he stopped that challenge.
Dead. He did not stop the challenge until he died.
Okay, can you Google it right now? I don't think he's dead. You'd be surprised. Oh, by the way, some people were not allowed to participate, and there was a lot of controversy behind that. But that's a whole different
Who's not
topic.
allowed to?
Like some actual psychics and people who could do phenomenal stuff. A lot of it is very controlled, unfortunately.
Yeah.
Well, I mean, you can.
James Randi
Yeah, he's still around.
Oh dear. He's Canadian. Did you not know that? He died in October last year, age 92.
Oh, he did die. Okay, but it was last year. But he stopped the thing like years before that.
Not that
Maybe
I
he
know.
was doing that.
I
I'm not
think you're
saying.
wrong on that one too, but here's the deal. I need to write it up still, but
Okay.
I would like to do a $10,000 challenge, and it would be paid in Bitcoin
Ooh.
for psychics to do a similar thing. I'll give three challenges. Do it live through Zoom. One of them would be to just describe one of the faces of this cube, and it would be sitting behind me on this shelf here before the video starts. And all they would need to do is project themselves and then tell me what the cube looks like.
That's a high level astral projector. You have to be like
If somebody can project, they can do that.
Easy 10 grand right there. For somebody who can do it.
So if somebody could, here's the deal. If I could do that, I would get rich instantly. And so.
Oh, there are some people who can, they use it for nefarious purposes. Like I saw a video of a criminal who used to do that. And that's how he would like get into banks and make a lot of money and hack. They're so, Mike, you hear it all the time. How did they hack into this bank? How did they get this information? How did they like do all this stuff? It's because they use it in a demonic way, unfortunately, not for good. But yes, it can actually go out of your body and do all that. And remote viewers, by the way, the government has been using remote viewers. I'm sure you've heard about this, Mike.
Certainly I've heard about it.
Yeah, remote viewers, and they've done like actual just to see where the enemy base is and everything. It's just, and police use psychics all the time for solving crime cases.
Do they? Yes. Okay.
Yeah, but
Um,
that's a whole different topic. But you do believe in the supernatural. God exists.
I do, but that's a whole different thing. I've never seen any credible evidence of people doing astral projection or remote viewing or any of that kind of stuff. So anyway, that's funny. Let's see. Andrew Stoll says, if the Earth was flat, I could get AM radio broadcasts from anywhere on Earth.
Because of the atmosphere thickness, it wouldn't be possible. I think so.
Again, sorry, Andrew. I think it's lost on him, but that's fine. Fumduckery says, everyone yell, I love modgets. Maybe he means I love midgets, because I love midgets. I do. Who doesn't love midgets?
They're the best.
All right. Magellan says, Santosh, look around one day. Drive around one day. Look at all the dishes and look at the cell phone towers. The dishes point in the same direction, regardless of towers. Give that a shot. Now, maybe if you're like living at 60 degrees north and the dishes are kind of they're angled down. When I was in Anchorage, it was quite striking how the satellite dishes were aimed much more angled down than in Minnesota here. We're 15 degrees different. So Stringer News 1 says, fun fact, the term Sataloon was coined by Gilmore Sheldall, whose company made the first balloon satellite to go to space, and airline barf bags. You know, I would always take those bags and I'd draw faces on them and talk. Who didn't? Come on. Who didn't? NA for $6.66 says, thanks MC Toon. Even with the clicking beer mugs and other stuff, I feel like I lost a few IQ points on the screen. Hail Santa.
Thank you. That's what I'm here for.
That's what he's here for, people. Now you know what? I missed one last week, and I'm like, crap, I didn't want to miss it, so I took a screenshot. And was it NANA? Yes, it was. So I'm going to read now NANA from last week that I missed. It says, spent a lot of my childhood south of the equator near the Tropic of Capricorn and now living in Boston, just observing the skies destroy flat Earth. Take that, Santosh.
Just his observation.
You can do an awful lot with observation, like the sun could never set due to perspective. All right, a Magellan. So thank you very much, NA. Magellan says again from Singapore, Santosh, if space is fake, why bother launching so many fake, expensive rockets? Why not just launch one big one once a year and save the money?
That's a good question. Well, it's there's a lot of money involved, right? Like NASA,
It's a lot
for
of
example.
wasted money if it's
yeah.
all
Well,
for fake.
It has to go somewhere.
Why would they? I mean, it totally makes sense. Just do it every once in a while, because people go to these launches. They're actually doing something. There's actually fire coming out of the back end of these rockets,
and it always has a curved trajectory,
as
like
it must be on the globe.
As it goes back into the ocean.
It doesn't go into the ocean though,
beyond the firmament.
Because if it's a globe, it has to get that lateral speed to orbit. That's the point.
There's always an explanation. So it makes it fun.
Absolutely correct. There is an explanation for the globe, and there generally is not for flat Earth.
Yeah. It's just funny. Every time a flat earther says find something new, there seems to be an explanation.
Doesn't that bother you that there always is a good explanation for the globe, and there generally is not a good explanation for flat Earth?
The question, though, that's all.
What's that?
Like the explanation was not there before the question. Like, for example, kid asks about Santa Claus.
It's because you didn't. The explanation was always there. You just didn't look it up. See, you got the question to ask from a flat earther, probably on YouTube or from a meme, right? And you didn't then go say, hey, I wonder how that works on the globe, and then go look it up for a globe. You just stuck with the one question that was offered you from a flat earther and did not do your own research. Because if you'd done your own research, you could have watched some videos. You could have stayed on YouTube and watched Scott Manley and see him talk about Delta V. Now, have you heard him talk about Delta V?
No, I haven't heard.
If you had, then you wouldn't say anything about why do they curve like that. They must curve like that on the globe. Because they don't just they would not just go straight up and then hang out there. In order to orbit, you have to have this very fast lateral motion.
And what about some terms like superior mirage? That seems like a new term. I don't think I've heard that before. This flat Earth.
Go read some nautical almanacs from 100 years or more ago. They've been around. Yeah, I mean, we don't deal with it in our regular day, so we wouldn't, right? But other people do, so it's something that they've discussed. So, the Sun Express again says, Santosh, when is the last time you could see cars drive from a commercial flight at 35,000 feet?
Well, I see it.
So at 35,000 feet, did you see cars?
No.
Okay. Why should satellites 400 miles away be easily visible?
I'm not saying it should be easily visible, but I would like to see, since you do launch all these things into space, I'd like to see one guy just take a video of the satellites or something, just to show us it's there, or something credible. Is that too much to ask?
There's lots of them. All you need to do is go look.
Okay, I'll look.
Don't include flat Earth in your query. Right? Don't go to flat earthers for this. There's lots. You will see some animations, absolutely, because when you don't have a third party camera viewing something, you can't have a third party view. But there's lots of videos of all sorts of things that you're asking for if you just go look. So that is a great question there, Sun Express. All right, Area 85 Restorations says, my standard question. You ready? I work at an engineer at a rocket launch and test site. How is it possible that I am being lied to, or am I part of the conspiracy too?
I'm not going to say that he's lying, but it's highly compartmentalized, right? So this person will be working on
How do you know?
That's what any
the flat earthers on YouTube told you.
If you work at a call center, it's going to be like compartmentalized. Like this person will be only doing this. This person. So imagine how much more complex a multi-billion,
and how much more complex it would be to hide any of this. So here's the deal: somebody that works at an engineer, as an engineer with the satellite, and monitors some part of the mission, and is like, well, I need to monitor that during many hours and days of that mission, right? And that person is interacting with the remote satellite, getting data from it, sending commands to it, right? If that person was compartmentalized and somehow hidden this information, that means that somebody else needs to be feeding him that data somehow. And probably not just one person. It'd have to be quite a few people because it all now needs to work, right? So Area 85 restorations now must be getting fooled by somebody, because he can't just be compartmentalized away, because he's interacting with the satellite somehow.
There's some information being fed.
So now you've got these other people on the other side of it that are in on it. And the ratio of people working on it to people in on it, it's got to be a pretty significant ratio now. So there's a lot of people in on it now.
It's kind of similar to the same thing like pilots. There was a pilot being interviewed by a flat earther, and he said that, do you know that they have to sign agreements when they're employed? And if they like report something that they see, like say, for example, a local sun and all that stuff, they will lose their license.
And your evidence for this is some flat earthers video on YouTube?
Well, there was an interview with an actual pilot. I mean, you can check it out yourself. And
actually,
these are actual people.
Where this actual pilot said,
yes, they have to, they could lose their license if they report something that
a local sun. If they see a local sun.
Well, there is video of that, Mike. Like I said, the sun was under the clouds.
We already covered that. It's not possible on flat Earth. It's only possible on a globe.
Not the light, Mike. The actual sun itself was submerged within the clouds. A local sun, and it's very compelling evidence. But of course, if you bring
it's actually impossible for flat Earth because the sun could not be that low. We already covered that.
If you let's get back to the thing.
Yeah.
If people don't want to lose their job or their livelihood, their family, they're going to be. So a lot of them, they want to speak out, but they can't.
So what you're saying is, somebody's like, you know what? I want to be a rocket scientist. I'm going to go to college and I'm going to get a degree in physics. Then I'm going to go get a master's degree. Then I'm going to go get a PhD. And now finally I get to go be a rocket scientist. I get to NASA. And you get to NASA and you're like, I'm going to design things, and I'm going to design the rocket. I'm going to do this. I'm going to do the calculations for this. And then somebody pulls you aside after all this work, says, yeah, we've just been faking it. What's that person going to do? You're like, yeah, faking it.
Really angry.
Yeah.
Very, very angry.
But that didn't happen.
There are NASA employees who have come and spoken out. There are videos of that.
No, there aren't.
Well, there's absolutely none. Are you sure?
I've never seen any.
Okay.
NASA astronaut saying, I was in on it. Nah, I've not seen any.
There was a video of Buzz Aldrin even saying that to a child.
Don't misquote that. Don't misquote that. She asked, why did we not go back?
Because
he said, because we just didn't go back. That's what he said. Don't misquote it. Don't take it out of context. That's dishonest. Santosh, that's just dishonest, and you're quoting a dishonest flat earther, and you bought that, right? It doesn't. It's incredibly dishonest. So say that again.
Sorry.
Say that again. It
Oh,
didn't
why
come
not promise them that? Like some guy showed him a Bible and said, "Okay, can you swear on this Bible that you went to space or to moon?" And even in a court, you're supposed to do that, right?
through. Yeah.
You solemnly tell the truth and nothing but the truth. And yeah, you have to place your hand on the Bible. But Buzz Aldrin literally punched the guy. And
So
I,
if
I'm not
well,
supporting
hold
the
on.
flat earthers, by the way. I'm not saying I thought he was very intrusive. I thought he was a bit annoying, but it seems like I'm not saying, but
Okay.
none of the astronauts, none of the ones that they approached swore on the Bible.
So none of the astronauts swore. But now, what would you say if one of them did?
I believe there was one guy who kind of like did just like a little pat or something, but the other ones didn't. As one guy even ran away from.
So what would you say if somebody did swear on the Bible?
That he went to the moon?
Yeah.
Okay. There's other astronauts that just
What would
run
you
away
say, Santosh?
Okay, I'll
what
see
would
it.
you say
I'll
if?
see it. I haven't seen it.
What's that?
I haven't really seen it.
Okay.
That,
So what would you say if one of the guys that went to the moon swore in the Bible that he went to the moon?
I would say, hey, you know what? At least from his perspective, he's being truly honest with it, God-wise, so that he's being honest with God and himself.
Okay, so, but what would you say? Because you just claimed that none of the astronauts that went to the moon would swear in the Bible that they went to the moon. So I'm just asking you a hypothetical. What if one of them did swear in the Bible that he went to the moon? What would that change your mind then? Because that seems to be a reason why you think that they did not go to the moon.
Maybe I wouldn't believe that still, but I would have much more respect.
Then why would you bring it up?
It just seems odd. I mean, why would you not swear on the Bible?
Matthew 5.
Don't you think that's a bit odd?
Because Matthew 5.
Okay.
Matthew 5 in the Bible says that you should not swear on anything. Let your yes be yes and your no be no.
And yet in court, we're supposed to swear on the Bible all the time.
Not the point, is it?
Uh-huh.
So now, what would you say if one of the astronauts did swear in the Bible?
I would have more respect for them, to be honest, because this is such a huge...
Would you say, oh, well, then that guy must have gone to the moon?
I wouldn't say he must have gone, but I would have more respect for him. That's all.
Why would you have more respect for him?
Because he's being honest to himself and to God. Like, yes,
Okay.
we did go to the moon, and I have nothing to hide.
Okay, so
Yeah.
so then you would believe him? He's being honest, so
Yeah.
you would believe him.
From his perspective, maybe he did go. I don't know.
What do you mean from his perspective? It's either he did or did not.
Maybe he was drugged and he was tricked
Come on.
into
Come on.
the moon.
Be serious.
That could happen. That
No.
could happen.
Be serious.
Brainwashing. There's all kinds of
Come on, be
stuff
serious. That's you can't be serious about that.
Have you tried some drugs that I haven't done any of them, but they said, oh, it's like a trip to the moon, just LSD.
Yeah, that I don't think that counts. I don't think that's what they're meaning. So, all right. Well, then, we'll see what you say here. See how you take it. Here's Eugene Cernan.
Is this a Bible?
Yeah, absolutely.
I
My
think
Bible.
this is ludicrous, and I want you to put that on film. It's ludicrous. I swear,
Under penalty of perjury,
I swear under penalty of perjury, treason,
and eternal damnation.
and eternal damnation.
That I walked on the moon during Apollo 17.
That I walked on the moon on Apollo 17 for 75 hours. I lived on the moon on Apollo 17 for 75 hours.
All right.
6 other astronauts did not swear.
All right.
6 other did not swear.
Well, how many did you say swore in the Bible? You said 0.
Okay, I have not
I
seen
showed
that.
you 1. There were actually 2 others. So a total of 3 did. So that must mean that they went, because you said that they did not go because they would not swear in the Bible.
I said it's odd that some of them were running away, and one
it's
guy was...
odd. Okay, so 3 people did swear that they went to the moon on the Bible.
3 people. Okay. I have not seen that footage.
mctoon.net/FE lies. Because here's the deal, Santosh. You heard some flat earther say that. You did not check to see if that was the case. You did not do your homework. And then you repeated the lie.
I saw the video of one of the astronauts literally running away from the Bible.
You claimed that none of them did.
That's a good point. You got me there. I didn't know that.
All right. You repeated a lie, Santosh.
Yes, I did. I'm sorry. I did not know.
Here's the deal, Santosh. Flat Earth is lies, and I've challenged you over and over on different lies tonight that you've repeated and not checked out yourself. So if lying is something that you don't want to do, then don't repeat things from other flat earthers that you've not checked out.
Okay. That's a good point.
You've done it a bunch. And what do you call a person that lies over and over again?
A liar.
Yeah. I know you don't want to be that.
Right? No, that's a good point. That's really
okay.
I should.
All right. Stringer News One says challenge for psychics. Guess my Bitcoin wallet number and just take the money. Not holding my breath.
That's a really good challenge.
My Bitcoin wallet number could be guessed as well, or my password on Bittrex. My username and password.
There have been some crooks who do very thing.
But
so you never know. But got to be careful with that.
I don't think that Mount Gox was hacked by remote viewers. Petermas Prime says Wolfie6020 has video footage of geostationary satellites taken with his telescope. So, Wolfie, do you know who Wolfie6020 is?
I think I've heard that name.
He's a pilot, a long-range international pilot, so his navigation requires really knowing how to do long-range navigation, which relies on the shape of the Earth that we're sitting on for accuracy, because he needs to know how far he's going to go in order to know how much fuel to put in, right? And he's in the Southern Hemisphere. He's stationed out of Australia. So on the AE map, all the distances in Australia or the Southern Hemisphere are drastically different than on a globe. They're closer in the Northern Hemisphere, but they're drastically different in the Southern Hemisphere. Yet somehow, using globe math, he can make it work. Anyway, so he has video footage of geostationary satellites taken with his telescope. So you can see them. They're just points of light. And then they get into the shadow of the Earth, and you can't see them anymore. And then they get out of the shadow of the Earth, and you can see them again.
Hold on. So you can see them using telescopes?
Yes.
Actual satellites in space?
Yes.
So wasn't it a while ago that you said that we can't actually see them from here?
We can't see all of them. Like, I can't see all of the...
I just want to see one of them.
You just want to see one?
Yeah, one
it's
satellite.
Easy to see. Yeah.
It's easy to see. It's easy. From here to
there's so many videos. Flat Earther Jaren got video of the ISS going in front of the moon.
I know the ISS exists. Yeah. Oh yeah, that a lot of people have gotten that. That's not, by the way, that's not in space. By the way, that's within the atmosphere.
It's several hundred kilometers high.
Yeah, it's within the atmosphere. It's within the Earth's atmosphere goes quite a bit, actually.
So space, there's a legal definition for space. That's 100 kilometers.
Okay.
So anything above 100 kilometers has legally or technically been in space. So the ISS is 400, I don't remember exactly, about 400 kilometers high. So it is in space in that. Now there is atmosphere. There is bits of atmosphere there. It's very, very thin.
Okay.
So, but the definition of space isn't there is no more atmosphere. The definition of space is
ISS compared to a satellite.
What's that?
How big is the ISS compared to the satellite?
It's much bigger than most satellites. Yeah. It's probably I'm pretty sure it's the biggest artificial satellite that we have. So Kiros says, I am a cartographer. I signed no waivers, but I learned the maths, he says, to create map projections and transform one projection to another. Am I a liar or being lied to?
No comment.
Has he been compartmentalized into being fooled? That his job is, yeah. Don't think so. That's the thing. These people are pretty smart. That
Yeah, they are.
it takes
There's no
a
doubt
smarter person to fool them in their own field.
Well, there's different kind of smarts, right? There's two people who are like they're very intelligent book wise, and then there's people that are more heart based. They just see and they know things.
Yeah, generally the heart-based people, we don't say that person's really intelligent. You might say he's really something else, some other word, but generally you're not like, oh wow, that guy's really intelligent because he can feel things.
Say
Use a
tribal
different word.
Okay, take for example. Here's a good example. A city guy who knows all the bookish knowledge, right? He doesn't know how to go and just live inside nature, like kill an animal and just survive, right?
Sure, he doesn't. But here's the deal.
Nothing wrong with that.
The person that is really good with the city knowledge and knows how to get around in the city, knows the stuff without from his head, to fool that person about how the city works would require somebody even better than him in that topic.
There's different layers, right? It's the top.
All right, we have Area 85 restoration. This is right to the point. Says I'll get to this Rocky Bixby. I'll get back to you. To elaborate on what Toon is explaining, compartmentalization would mean I literally could not do my job. How would I know if what I did is working correctly if I didn't have accurate data?
That's a good point. I guess, but who's approving the data? Is it just his boss?
What do you mean approving the data?
Like the data that's coming in, right?
He's
giving him the data.
He's interacting with the device. So nobody's approving the data. He's just getting it from the device. He says, hey, device.
And who programmed the
sends
device?
it back. The people that he works with.
There you go. There's always.
But
it's
they're in the same compartment. Typically,
Yeah.
they know each other. They're like, I need this to do this. Okay, I'll write it. All right. And they work together. And now they're like, okay, your program isn't working. Can you adjust it before we, send up the next satellite or send this satellite up? So, ooh. Mute Donkey says, not sure where in Canada Santosh is, but the ISS is heading in Canada. Will be in Canada in the next hour.
I'm in Ottawa. So
Ottawa. It's all
Ottawa.
Canada. Who knows?
Yeah, of course, with Americans, it's one big land up north.
It's just, it's actually here's the truth, people.
Yeah.
The ice wall isn't Antarctica. It's actually the United States and Canadian border. You get up to Canada, it's an ice wall. There's nothing past it. It's all fiction. It's all fiction. So, yeah, that's the thing. These people, they're interacting with the thing that they created. They know the thing that they created. In order for it to be faked, the thing that they created would have to now be manipulated by somebody else that knows their thing as well or better than them, so that they can feed them the data that in real time, because you send a command to it, it comes right back, right? Would have to feed that data in real time to them.
Right.
How could that happen? It could not happen. I can tell you with 100% certainty that the software that I write, nobody could fake it. Nobody could be on the other side, and I don't actually receive email. My software doesn't actually process billions of emails. Nobody could fool that. Nobody could fool me on that my software was actually doing it, because they'd have to manufacture all of the emails that I see. They'd have to manufacture the data. They'd have to manufacture the problems that my software experiences, because it's not free of bugs. I do something wrong, there's ramifications in the emails that I interact with. I can't get faked on that, because it's all just, I know it so well. Nobody could do that. I don't know what you do. Right? What do you do for a living?
Who, me?
Yeah. I'm not talking.
Yeah,
Nobody else here. What's that?
By the way, I do comics for a living too. Like, just wanted to plug
Oh.
that in. Trollcatcomics.com.
Oh, cool.
I released a book recently.
Yeah. I might order me one.
Yeah, I'll send you a signed copy actually. All
right.
Anyway, I'll do that at the end of the show.
So could how can I, is there an analogy to this? I don't know if there's an analogy to making comic books to this. So, all right. Anyway,
Panels. They're all compartmentalized, the panels.
So you say, yeah. Oh, in your comic book.
Okay.
That's the actual compartmentalization. Got it. All right. Stringer News 1 says trafficking in lies is like trafficking drugs. You're not innocent because you didn't make them. You're guilty because you've delivered them.
Oh.
Deep Thoughts by Stringer News 1.
Very nice.
Yeah. All right. Kiros says, when I learned people believed the earth is flat, I spent 4 years on and off trying to create flat earth maps. Either it's impossible or the maths simply doesn't exist. So this is the cartographer again.
So it's impossible. And yet they do have a map though. There is an AE map and there's more and more accurate maps.
The AE map is greatly distorted.
Okay.
So if the earth is flat, a non-distorted map would be the easiest type of map to make. Right? All the distances would be easy. In order to measure the distance, you'd put a ruler down on it and you'd measure the distance. You'd be done.
Well, it's a circle, right? It's not like it's going to be a little bit more complicated than just like.
Why would it be complicated? A flat map of a flat surface is the easiest type of map to make.
Okay.
There's no projection needed. There's no complications. It's just, here's the coordinates for this. Here's the coordinates for this. Boom. That works.
Yeah.
The straight line distance, we can use two-dimensional formulas to calculate the distance. We can then travel them to compare the prediction to the actual distance. And they would work, but they don't. Right? The distance from Sydney to Santiago on an AE map is about 2.5 times the distance that the plane actually flies. And it's a drastically different route. It doesn't work. Cartographers just laugh at it, right? I don't know why Kiros is here. I mean, it's silly to think that the earth is flat to a cartographer because their job is to do this very thing. So, anyway, it's almost 3 hours here.
Yeah, it's been really fun. I see you got a lot of tabs open.
I do have a lot of tabs open. All right, let me. I'm gonna check something. You, Boop, tell us about your comic.
Oh yeah, sure. It's basically a very mischievous cat. He doesn't really like to follow the rules. Like, for example, he's at the airport in the cover, and you're not allowed to take a certain amount of liquid, right? So he has a whole bottle of wine, and she says, no, you can't, take that with you. So he just chugs the whole wine right there. So it's like a little funny stuff like that.
That works. I think that's fun.
Yeah. So yeah, if you want to order it, you can just go to trollcatcomics.com. You will see a lot of other comics there as well. So yeah, just if you like it, I've tried to update every week, and there's a Facebook page for it and stuff like that. Yeah, cool. I'll send you a copy.
Let's see. I was looking. Is the plot hole was gonna do something today? People in chat, did the plot hole wind up doing that? He's gonna do a 5,000 subscriber special or something.
Wow.
All right. Yeah. All right. Because I don't see it on his channel. What's it called? Trollcatcomics.com. Let me see if I. Okay.
Yeah, you can leave it in the chat if you want.
Yeah, I'll put it in the chat.
Thank you.
All right, he had his thing earlier. Okay, there it is. I put it in the chat for you.
Right.
There. Oh, you're even on Amazon. Awesome.
Amazon, Barnes and Noble, some local stores.
Cool.
Yeah.
Well, here's what I'm going to do. We're going to wrap this up. I'm going to do a short after show.
Okay.
So let me do just a second. Everything's a little pokey here. I got the fans cranked, but I need to make visible the after show. But Santos, thank you very much for coming on. It's always a good talk with you.
Yeah.
So, all right, let me see. After show is now public. All right. So, it's going to be a panel. If anybody wants to join, send me a message. Santosh, you're invited to stick around too if you want. So,
It's about 12 o'clock here, so.
yeah, I just want to be inviting. So,
Thank you, though. I appreciate it.
all right, people, thank you so much for everything. It's been a good time talking to you, Santosh. I hope you do apply the same critical thought.
Yeah, I will.
And actually don't just look at the claims, but actually try to check them out. So,
Mike, look at the globe from a new perspective. And who knows? You might become a flat earther in a couple of years. You never know. Your show might have to change, though.
Things would have to be explained like sunsets. But all right, everybody, we will see you later. Bye.
Take care. Thank you so much, Mike.